Hello everyone. In this video session, I am going to explain part 216 of Java for Tester series, that is abstract classes and their fields. So abstract classes and their fields. So to understand this, let me ask few questions. That is, can we create fields inside these abstract classes? Can we create fields means variables, guys? Okay, fields are nothing but variables in Java. Okay, can we create fields inside the abstract classes? The answer is yes, we can create. Okay, yes, we can create fields inside this abstract classes. So the second question comes up here is, are there any restrictions or any any are there any restrictions or any differences between the fields created in abstract classes and normal classes? There is no difference, guys. There are no restrictions or no differences. Okay, if you create some fields inside this abstract classes, it's actually same as the fields that are created in the normal classes. Okay, there's no much restrictions there. Unlike interfaces which I have explained in one of the previous videos. Okay, in interfaces, if you create some fields or variables, okay, they are by default final and static type, right? The variables or fields created inside these interfaces are by default final and static type. But coming to the abstract classes, there are no such kind of things, guys. Okay, their abstract classes are like normal classes. If you create some variables or fields inside this normal classes, it's actually same as the creation of the variables and or fields inside the abstract classes. Okay, to confirm that, let me create an abstract class and show you that there is no difference. So let me create a normal class, say animal. Here you can create anything, and I will make this animal class an abstract class by adding subject non-access modifier. Inside this abstract class, I am going to create some fields, that is variables. Int speed. Okay, int speed is the field or variable. So I can actually add private here. I can actually add protected here. There are no restrictions, guys. Okay, private, protected. What is the other one? Public. Then default. Okay, it's like normal class. There are no restrictions here. And also, these are like, you can actually create some non-access modifiers also before them, like final. Okay, final means you have to give some value. Okay, the final value you have to give here, or you can say static. Okay, static also you can mention like this. These are normal fields, guys. Okay, the fields created in the normal class are same as the fields created inside the abstract class. There are no much differences. But coming to the interfaces, there are some restrictions for these fields, guys. If you create some fields inside the interfaces, by default, even though you don't specify final static, those variables or fields inside this interfaces are treated as final and static by default. Internally itself, they are final static. But coming to the abstract classes, they are like normal classes, guys. What are the variables or fields that you create inside these abstract classes are same as the variables or fields that are created inside the classes. Okay, so there is not much difference between the normal classes and abstract classes with respect to the fields. Okay, so that's it about the abstract classes and their fields, guys. In the next video session, I'll continue with the other abstract classes concept, that is abstract classes and constructors. Abstract classes and its relation with the constructors. That thing I'm going to explain in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I am going to explain part 217 of Java for Tester series, that is abstract classes and constructors. Abstract classes and constructors. To understand this topic, I'll ask few questions. Okay. The question here is, can we create constructors inside the abstract classes? The answer for this question is yes. Yes, we can create constructors inside the abstract classes. Unlike the interfaces, in interfaces, we cannot create constructors, guys. If you try to create constructors in the interfaces, you are going to get the compiler error. Okay, the interfaces, there is no possibility of creating the constructors, but coming to the abstract classes, they allow you to create the constructors. Let me practically show you the same. So let's first create a new class. I'll name this class as any class you can give here. I will name it as animal, and it's a normal class. Not to make this an abstract class, I'll just simply add abstract non-access modifier before this class. Now this class has become an abstract class. So inside this class, I'm going to create a constructor. So public constructors will not have any return type. So, and another rule for constructor is the name of the constructor is same as the name of the class. Animal. Okay. Public animal. So you see, I'm not getting any compiler error. Okay. System.out.println inside animal class constructor. So there is no restriction, guys. There is no restriction in Java where you are creating constructors inside the abstract classes. Abstract classes allow you to create the constructors without any problem. You will not get any compiler errors. But coming to the interfaces, as already explained in one of the previous videos, let me create an interface, say bank, and I'll try to create a constructor inside this interface. And as you can see, you are going to get a compiler error in case of this is an interface case. In this case, you are going to get a compiler error. So public bank, the name of the constructor should be same as the name of the interface or class. If I try to do so, as you can see here, I got a compiler error saying that interfaces cannot have constructors. Interfaces cannot have constructors, but abstract classes can have constructors. So guys, abstract classes allows you to create constructors without any problem. So that's it, guys. In the next video session, I'm going to explain the interfaces and the method body. Okay. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 218 of Java for Tester series, that is interfaces and method body. Interfaces and method body. Till the previous video, I have covered all the topics related to abstract classes and interfaces. But there is only one topic left, that is interfaces and method body. So let's start this session with a question. That is, can we create a method having body inside the interfaces? What is the answer for this, guys? Can we create the methods having the body inside the interfaces? That is, can we implement the methods inside the interface is the question. So the answer for this particular question is, it depends, guys. Okay. It depends on what version of Java we are using. It depends on what version of Java we are using. There are two possibilities here. For example, the Java version that you are using is less than 8. Okay. We are using a Java version which is less than 8, that is 7 or 6. Okay. In such kind of cases, the answer for this question will be no. That means we cannot implement methods inside the interfaces. Okay, we cannot implement the methods inside the interfaces. The interfaces cannot have the methods having body in the Java versions which are less than 8. Okay, inside the interfaces we cannot implement the methods for the Java versions which are less than 8. And here, what is satisfied? 100% abstraction will be there here, guys. Okay, in this case of Java version less than 8, we have 100% abstraction possible. But from the Java version 8 onwards, okay, 8 or greater than 8, 8 or greater than 8. In this kind of Java version, it's possible, guys. Okay, from Java 8 onwards, it is possible to create or implement methods inside the interfaces. But there is a clause, that is, in order to implement those methods inside the interfaces from Java 8 version onwards, okay, those methods need to be specified with either default or static modifier, okay. Only for the methods which are specified with this default or static modifier from Java 8 onwards, okay, they are allowed to be implemented inside the interfaces. All the other methods cannot be implemented, guys. Even after Java, even from Java 8 onwards also, if the methods are not specified with default or static, they are abstract by default, okay. They are public and abstract by default. They cannot be implemented inside the interfaces. Only for the methods which are specified with the default and or static, okay, those methods only can be implemented inside the interfaces. Let me practically demonstrate this for you guys, okay. So for that, let's go to this Eclipse IDE where we have this project, okay. So let's find out whether what version of Java is available, okay. So right click on this project, say properties, and select this Java compiler option. When you click on this Java compiler, the screen will load. And as you can see here, which version of Java is currently selected, guys? As you can see, 1.8. That means Java 8 version is there. That means we can implement the methods which are specified with default or static modifiers. Okay. Since this project is specified with Java 8 version, okay, we can actually implement the methods inside the interfaces which are specified with default or static modifiers. Okay. So fine. Now what I will do is I will simply, since it's already set, if it is not set, guys, in your case, if it is not set, okay, then select this option and change it to 1.8, okay, and then say apply and close, okay, if in case Java 8 is not there. Now, when the Java 8 is set for this Java project, then say right click, say new and say interface. Let's create an interface like this, and I'll give some name for this interface. Let's say bank. Okay, I'm just creating a bank interface. Bank interface got created, guys. Inside the bank interface, let's create some methods. So if I say void method A, so if I say void method A, this method A is by default public and abstract, even though I didn't specify public or abstract here, but the methods inside the interface are by default abstract and public. Okay. So if I try to create a body here, I will get a compiler error because this method is by default abstract. Okay. And also public at same time. So I should not be providing any body. But I said that we can create methods inside the interfaces. I said that we can implement the methods inside the interfaces. That is, methods having the body can be created here, I said, from Java 8 onwards. So let's see how to do that. Those methods should have this default or static specified, guys. Then only that kind of methods are possible. Let's start with default. Default, if I say void, then method B, and if I try to create a body for such kind of methods which are specified with this default modifier, you see, I'm not getting any compiler error. Java is allowing you to create such kind of methods with body inside the interfaces. So here I will say inside method B of bank interface. Okay. Similarly, here I will say inside default method. Okay, default method B. So another method I will create. This time I'll use another modifier known as static. So I'll start with static. Static void method C. So this method also I can implement, guys, because it's specified with static modifier. This particular method specified with static modifier can be implemented. Okay, I'm not getting any compiler error. I'll simply type down inside static method C of bank interface. I can implement. Okay, inside the interface, I'm able to interface. I am able to implement the methods, guys. Okay, methods implementation is now possible when they are specified with default or static from Java 8 onwards. Okay, the normal method which is not specified with the default or static has to be, cannot have the method body, guys. Okay, because it's by default public and abstract. It cannot be implemented. Now, guys, so far so good. Now what I'm going to do is I'm going to access these methods, okay, from this interface. For that, let me create a class. Right click new class. I'll name this class as demo and select this public static void main. I'll drag it to the right side so that you can see both the interface and class at the same time. Inside this main method, I wanted to write the code for accessing these methods inside this main method. How can I do that, guys? Can I do it or not? In order to access these methods, I need to create an object, right? I need to create an object for the interface. Is it possible to create an object for the interface? It's not possible, guys. You cannot create objects for the interface as per the rules. As per the Java rules, we cannot create objects for the interface. If you try to do so, you'll get the compiler error. Let's say if I say bank B is equal to new bank, okay, you'll get a compiler error, guys. Okay, you'll get a compiler error saying that cannot instantiate the type bank. That is, you cannot create an object for the interface. It's not possible. So what we have to do, guys? You are not able to create an object for the bank interface, and without object reference or without object, we cannot access these methods. So what's the way? The only way is to create a child class for this interface. That is a class implementing this interface we need to create. So let's create a class. So I will say this, I will name this class as Access Bank class. You can give any name here. Click on finish. So drag it to here so that you can see both all the things together, like bank interface, demo class, Access Bank class, and all those stuff. Okay. I want to make this Access Bank a child class of this bank interface. That is, I want to make this Access Bank implement this bank interface. So for that, we have to use a keyword known as implements keyword. Implements bank. Okay. Access Bank class implements the bank interface. So what will happen when a particular class tries to implement the bank interface or interface? All the abstract methods inside this interface has to be implemented here. Otherwise, you will get a compiler error. You see, it's already saying that the type Access Bank class must implement the inherited abstract methods of the bank interface. It is also specifying the method that has to be implemented here. Okay, method is abstract method here, which has to be implemented in the class which is implementing the interface. So let's hover the mouse here and say add an implemented methods. Okay, this method A will be implemented here now. Okay, I will simply write down saying the system.out.println inside, okay, method A, okay, inside method A, inside method A implemented in which class? Access Bank. Okay, Access Bank class has implemented this abstract method of the bank interface, guys. Okay, that's what I have written here. That's fine. Now, since I have created a class for this interface, okay, since I created a class which is implementing this bank interface, and I'm not able to create an object for the interface because as per the Java rules, I cannot create objects for the interfaces, right? That's not possible. I already showed you. So how to access this these methods of this bank interface? By creating a class and implementing the unimplemented methods, okay, and implementing the unimplemented methods here. Then we have to create, we can create an object for this Access Bank class, okay. Even though we are not able to create an object for the interface, we can create an object for the class which is implementing the interface, and using that object reference, we can access all these methods, right? So instead of creating an object for the bank interface, I'm going to create an object for the Access Bank class which is implementing that interface, okay. So I'll simply say Access Bank A is equal to new Access Bank. I can create an object for the class which is implementing the interface without any problems. Okay. And using this object reference, I will try to access the methods. Okay. I will say A dot. I'll try to access this default method base. Okay. I'll try to access this default specified method. Okay. So I'll say because this particular default method will be inherited by this Access Bank class. So using the object reference of that class, I can actually access that method B. Okay, default method I am able to access with the object reference. Second thing is I would like to access this method A, which is implemented in the Access Bank. Okay, which abstract method of the interface which is implemented in the child class of this interface, that is Access Bank. So for that also I can simply say A dot method A. This is also done. So what about this static method, guys? Do you have to use this object reference to access this static method? It's not required, guys. It's not required for you to use this object reference for accessing this static method. If you go back to the previous videos, okay, in one of the previous videos where I explained about the static modifier, okay, a particular method is specified with a static modifier, and if you have to access such kind of methods, and if this particular method is inside a class, okay, if this particular method which is specified as static is inside a class instead of an interface, what we used to do, guys, we used to use the class name to access this method, right? Class name dot method C we have to say in that case. But in this case, we have this Instead of class, we have the bank interface, guys. In this case, instead of the class, we have the bank interface. So how to use this, how to access this method C, which is inside an interface and specified with the static modifier. The same thing will be there for the interfaces also, guys. You have to use the interface name dot method C. Okay, you don't have to use object reference for accessing the method specified with static. Instead, we can simply say interface name dot method C. Bank dot method C. Here in this case, this particular method belongs to the interface memory, not the object memory, interface memory, because it specifies static. If in case this method is inside a class, this method would have been belonging to the class memory because it was specified with static. But here, there is an interface, guys. So this method will belong to the interface memory because it's specified as static. Okay, that's the difference, guys. Fine. Now, guys, what I will do here is, you can see that instead of using the object reference, we are able to access this particular method C, which is of static type, using the interface name, that is directly bank.method C. Very simple. Fine. So far, so good. Again. Now, one more thing I would like to explain here before concluding this session is, here I have used some new keyword. Okay. Till the previous videos have not used this default keyword. Okay. This is the first time I was using the default keyword with the methods. I just want to see if I can use this default keyword also in the classes. I'm able to use this default keyword inside the interfaces. Okay, for the methods inside the interfaces, I was able to use the default keyword. Everything is working fine. What if I use the same default keyword with the methods inside the classes? Here, Axis Bank is a class. What will happen if I try to use this default keyword with the methods inside the classes like Axis Bank? You will get a compiler error, guys. It's not allowed. Okay, let me show you. Default void. If I try to say method D, okay, create a method D, implement it. System.out.println inside method D. Okay, if I say something like this, you see this method D, as I specified this with the default keyword, is giving a compiler error saying that default methods are allowed only in interfaces. Okay, you cannot use this default keyword any other place. Okay, only in the interfaces, that too before the methods. If you want to implement such kind of methods, you just have to provide this default keyword. But if you try to use the same default keyword with the methods inside the classes, you are going to get a compiler error saying that it's not supported. It's only supported in the interfaces. Okay, this is only supported in the interfaces, guys. Okay, so default keyword can be used only with the methods which are there inside the interfaces, and with the classes it doesn't work. It will give the compiler error. And one more thing I would like to explain before concluding is, what if the Java version is less than 8? Will I be still able to use this default keyword and static keyword and implement these methods inside the interface? Is it possible? Let's find it out. It's not possible, guys. Okay, so I'll right click on this project and select properties, and I will select this Java compiler. I would like to change this version. Okay, I want to make this version less than 8. So for that, I will deselect this and then select this 7. Okay, which is less than 8. Select this, apply and close. Okay, now guys, save it. So did it change or not? Let me check again. Properties, it's not changed, guys. So I should not be selecting this. Okay, I have to simply select 1.7. I should not select this checkbox. Otherwise, it will change to 1.8 again. Apply and close. Yes. You see, immediately after clicking apply and change, I'm getting the compiler error for this two methods which are specified with the default or static, because these things are not there in the Java versions which are less than 8, guys. Okay, only from Java 8 they are allowed. Okay, only from the Java 8 onward, this default methods and static methods have been introduced inside the interfaces. Okay, before Java 8, inside the interfaces, we don't have such kind of keywords to be used before the methods, and you cannot even implement the methods also. Okay, only abstract methods which are public type can be allowed. But here, I try to use default static in the Java 8 version, which is not possible at all. Okay, over the mouse says default methods are only allowed from the Java 8. It is saying, simply it's saying that these methods cannot be there. Okay, in the Java versions which are less than 8. Only from Java 8 onwards, we can use such kind of methods and implement them inside the interfaces. Fine. So it's clear now. So again, let's go to the right click properties and then select this option, guys. Now the Java version got changed to 8. Okay, apply and close. because we'll be using this Java 8 version for the other sections of the videos, okay, in the upcoming videos also. So better to change it back, guys. Don't forget to do so. So guys, this is all about the interfaces and method body. So from Java 8 onwards, we can implement the methods, okay, inside the interfaces, that too by adding or specifying the default or static keywords or modifiers before the methods, okay. Only for such kind of methods specified with the default or static can be implemented inside the interfaces from Java 8 onwards, as explained in this video session. So that's it, guys. In the next video session, I'll start explaining about the collections framework. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 219 of Java for Tester series, that is collections framework. So what is collections framework? Collections framework is a huge topic in Java, guys. Okay, it comprises of several predefined classes and interfaces. Okay, so some several predefined classes and interfaces together we call that as collections framework, guys. Okay, there are huge number of classes and predefined classes and interfaces in Java, which together we call them as collections framework. What are these different predefined classes and predefined interfaces which form this collection framework? That I am going to list down soon. Okay, that I am going to list down soon, guys. The names of the classes and interfaces which together form this collections framework, I am going to list down soon. Okay, before I list down those things, let's find out the purpose of this collections framework. The purpose of the collections framework is to use this predefined classes and interfaces. Okay, the purpose of the collections framework is to use this predefined classes and interfaces for, why we have to use this predefined classes and interfaces? For grouping, okay, individual objects into a single entity. Okay, for example, guys, we have, like, let's say there are different objects, student objects. Okay, student objects are there, student object 1, object 2, like that, something. Okay, just assume that there are multiple objects, and if you want to club all these objects together into a single entity, okay, these are individual object. Object 1 is separate object, object 2 is another object, object 3 is another object. If you want to group them into a single entity, then we have to take the help of this predefined classes and interfaces of this collections framework. Okay, using this predefined classes and interfaces of this collections framework, we can group the individual objects into a single entity. That's the purpose of the collections framework, guys. Okay, anyhow, how to group these individual objects into a single entity, I'm going to practically demonstrate using these predefined classes and predefined interfaces in the upcoming videos. Okay, at a high level, just understand the purpose of this collections framework and its predefined class and interfaces is to group the individual objects into a single entity. Okay, so practical explanation will be followed in the upcoming videos. Okay, will be explained in the upcoming videos. Now, guys, now as you understood the purpose of this collections framework, that is to group the individual objects into a single entity. Now let me list down all these predefined classes and predefined interfaces which together form this collections framework. Okay, for that, let me go here and let me name this as collections framework. Okay, let's name this as collections framework. Let me take this model for explanation. Under collections framework, we have collection interface. Okay, one of the root interface of the collections framework is collection, and in parallel to that we have another interface known as map interface. So we have multiple roots. Collections framework is a kind of concept, guys, which includes several interfaces and several predefined interfaces and predefined classes. So coming from the top, collection and map are the two things. Apart from this, we have other things also. Okay, other things also. But at a high level, collection and map are important. Fine. Under collection interface, I means I have kept here I because to name it as an interface. Collection is an interface. So if I say under collection, if I say tab, under this collection, what we'll get here is something like list interface. Okay. List interface is the child interface of the collection interface. And we have another interface which is also a child interface of the collection interface, that is set interface. Set interface. Set interface is also a child interface of the same collection interface. Another interface we have is queue interface. Okay. There are 3 child interfaces under this collection interface of this collection framework. Under the list interface, if you expand this list interface, we have array list class, guys. For class, I am representing the classes with this C symbol. For interfaces, I am representing with I symbol, guys. For classes, just for representation, guys, you don't have to type C every time. Okay. You can simply say collection list set queue. Just for your understanding, I'm just adding this inside the bracket. I'm adding I because this is an interface. Okay, so that you will know this is an interface. Here, array list is a class, so I'm just mentioning C as a short form, so that array list is a class. Array list, we have another one known as linked list. Okay, array list, linked list. Then we have something known as vector. Vector is also a class. Linked list is also a class, predefined class. Under vector, we have something known as stack. Okay, stack is a child class of this vector class. Array list, linked list, and vector are the child classes which are implementing this list interface. List interface is implementing this collection interface. This is a child of this collection, like hierarchy is there. Okay. So now we are done with the list. Let's go to the next item, that is after list we have set and then queue. So let's go with set now. We have something known as hash set class. Okay. Then as a child class of this hash set class, we have linked hash set. Linked hash set. This is also a class. There are several interfaces and classes. As you can see now, collection framework is a collection of different interfaces and classes which can be used for, what is the purpose, guys? For grouping the individual objects. For grouping the individual objects into a single entity. Okay. For grouping individual objects into a single entity, we have to use this predefined interfaces and classes. And under set we have asset and linked asset. Apart from that, we also have under set we also have sorted set, which is an interface. Okay, under set interface we have sorted set interface. Under sorted set we have navigable set interface. Under navigable set we have tree set class. Okay, tree set class. Fine. So we are done with the set interface hierarchy also. Now let's move to the third item, that is under collection interface we have list, set, and queue. So let's move on to the queue. Coming to the queue, we have priority queue class, and we have blocking queue class. So under blocking queue class, we have some child classes, guys. Okay. So let me take this model. Fine. Under blocking queue, we have child classes. One is priority blocking queue. Priority blocking queue is the child class of the blocking queue class. Like that. Okay. It's a class. And we have linked blocking queue is another class which is a child class of this blocking queue of this queue interface. Okay. Fine. And there are several other classes also. Okay. Apart from this priority blocking queue and linked blocking queue, child class of this blocking queue also has some other child classes also. Okay. Which are not that much important to be listed here, guys. So I am saying other classes. Fine. Now we are done with list, set, queue under the collection interface. Okay. Now let's move to the, in parallel to the collection interface, we have the map interface. Okay. Under collection framework, we have collection, map, and other. Under collection, we have list, set, queue. Apart from collection, we have map. Okay, this is one part like this. Okay, I just completed the collection part. Now let me move to the map part. Under map we have hash map class. Okay, then we have linked hash map class is also a class, guys. Then we have weak hash map. This is a class. Then identity hash map. This is also a class. So as you can see here, linked hash map is a child class of this hash map class, which is a child of this map interface. Under map interface, we have hash map, weak hash map, identity hash map. Then we have hash table. Okay, it's also a class, but there is some difference, guys. So far, whatever you have written, double worded things that you have written, here array list is there. A is capital, list is capital. Linked list, L is capital, L is capital. Two words. Okay, whatever the classes or interfaces which have the two words, they are each and every word inside this interface or class is a capital letter. Hash set, H is capital, S is capital. Linked hash set, sorted set, everything you see navigable set, free set, like that. Priority queue, PQ are capital. Blocking queue, BQ are capital, like that. Okay, all the things are like that. Here in map also same thing. Hash map, H is capital, M is map capital. L H M are capital. W H M, I H M all capital. But coming to the hash table, guys, this is kind of different. Okay, here hash is a separate word and table is a separate word, but this T is small only. Okay, you have to remember this. Okay, apart from all the other interfaces and classes having the multiple words, where each and every letter of the starting word is of capital. It may be the word may be in between or at the end, but the starting of that word is capital. But coming to the hash table, it's not like that, guys. H is capital, but T is not capital here. Okay, you have to remember that. Okay, now there is a child class for this hash table, that is properties class. Properties class. And to this hash table, there is a separate parent class. Okay, hash table has a, apart from this map interface, this hash table has a separate parent class, guys. For that, I am going to draw something like this. The name of this parent class is dictionary. Okay, dictionary class is there. Dictionary is a parent of this hash table, and property is a child of this hash table. Hash table is a child of this map interface, like that. Okay, fine. So apart from this hash table, under the map, we also have something known as sorted map interface. This sorted map interface. As a child interface of the sorted map, we have a navigable map. Again, this is an interface. Okay, sorted map, navigable map. Then here we have tree map. This is a class, predefined class. Okay, so these are all the things which are under the map interface, guys. As you can see, this is a map interface. Okay, collection interface, we have very big hierarchy where collection has this list set and queue. Under list we have multiple child classes. Under set we have multiple interfaces and child classes. Under queue we have multiple child classes again. Okay, this is a collection part. Coming to the map part, this is a map part that I have just now drawn. Hash map, linked hash map, weak identity hash map, and then hash table properties. Hash table has this dictionary, and then sorted map, navigable map, and tree map. Okay, like this. So apart from this collection and map, we have other part also. Okay, so this other part is nothing but there are other interfaces and classes, miscellaneous interfaces and classes, which I am trying to group in the other section. Okay, so I would like to categorize them, guys. Okay, the remaining miscellaneous predefined classes and interface of this collection framework, apart from this collection hierarchy and map interface hierarchy, whatever the remaining predefined class and interface are there, I would like to categorize under this other section of this diagram. So under other section, I would like to categorize them as something known as cursors. There's concept known as cursors, guys. Cursors is not an interface or class here, guys. Okay, I'm just naming it just for categorizing purpose. Okay, this cursors is neither a class or interface. Okay, I'm just categorizing this miscellaneous classes and interface under this cursors part. Okay, so under cursors we have different things like enumeration. Okay, enumeration is a predefined interface. Okay, which falls under the cursors category of this collections framework. And then we have Then we have iterator interface. And this iterator interface has a child interface known as list iterator. Okay, list iterator is the child interface of this iterator interface. So cursors is done. Other section I would like to categorize and name it as is sorting. Okay, why I'm naming this as sorting? All the classes, all the interfaces or classes which I'm going to write down under this sorting, okay, which are nothing but interfaces which I'm going to write under sorting, can be used for sorting purpose. Okay, these are for iteration purpose. I'll explain you more about this iterator and list iterator in the future videos anyhow. But based on the categorization, I just named it as cursors. We generally call this iterator, list iterator, enumeration as cursors. Okay, that's why I named it as cursors. And under sorting, we have different things like comparable interface, and other one is comparator interface. Okay, these are the two interfaces which fall under the sorting category of this collection framework. Cursors, sorting, and one more thing is also there, that is utility. There are some utility classes. Okay, there are some utility classes. What are those utility classes? Let me show you. Under utility classes, we have collections class. Okay, a predefined class known as collections class is there, and another class is also there, another predefined class known as arrays. Okay, this arrays is a predefined class, guys. Okay, it's not a concept, it's a class. So collections and arrays are the predefined classes which fall under the utility classes of this collection framework. So this is nothing, this complete together is known as collections framework, guys. Okay, under collections framework we have several predefined classes and interfaces. They are well categorized as part of the hierarchy. As you can see, they are well categorized. But at a high level, if you speak about collections framework is nothing but a collection of several predefined classes and interfaces. Whatever the predefined classes and interfaces I listed down here, which will form the collections framework together. Okay, and the purpose is to group individual objects into a single entity. Grouping the individual objects into a single entity is the purpose of this several predefined classes and interfaces of this collections framework. Fine. So collections framework at a high level is categorized into collections interface, map interface, and other classes and miscellaneous classes and interfaces. Okay. Under collection interface, we have three sub interfaces, that is list interface, set interface, and queue interface. Under list interface, we have Arraylist, linked list, vector, and as a child class of the vector class, we have the stack class. Under set interface, after list, we have set interface. Under set interface, we have hash set and its child class linked hash set class. And apart from this, we have the sorted set interface, navigable set interface, and tree set class. That is about the set. Coming to the queue, we have priority queue, blocking queue. Under blocking queue, again we have the child classes like priority blocking queue and linked blocking queue and other miscellaneous classes which you don't have to learn. And this is the queue. So collections is comprising of list interface, set interface, and queue interface hierarchies. Then after collection, we have the map. In the same level of the collection interface, we have the map interface. Under map, we have hash map, linked hash map as a child class of this hash map, weak hash map class, identity hash map class, hash table class. It has a child class known as properties, and this hash table class has a parent class known as dictionary class. And apart from that, this map interface has a sorted map interface, navigable map interface, tree map class. Okay, this is a map part. Fine. And other miscellaneous classes and interfaces are cursors, sortings, and utility classes. Okay, I'm just categorized this different predefined classes and interfaces which fall under the other category of this collection framework into the cursor, sorting, and utility classes. Okay, just naming, guys. These are neither classes or interface. These are just written for naming and categorizing purpose. We have several interfaces like enumeration, iterator, list iterator, child interface of this iterator interface. Under sorting, we have comparable interface and comparator interface. And utility classes, we have this collections class and arrays predefined class. Okay, so if we have to learn the collections framework, we have to learn each and every interface and predefined class which is specified. Okay, under this hierarchy, whatever the complete list of predefined classes and interfaces has to be learned here. Okay, every predefined interface and class plays a major role in the collections framework anyhow. There are a lot of differences between each and every predefined class and interfaces that are listed down here. But do we have to learn everything, guys? As testers, you don't have to learn everything mentioned here, guys. Okay, as testers, you don't have to learn all these things that are mentioned here. Okay, whatever that is important, okay, I will explain everything in the upcoming videos. All these predefined interfaces and classes and how to use them, that I'm going to explain in the upcoming videos. Whatever the predefined classes and interfaces which are really required for us to use as testers, I'll be explaining this. And also few classes and interfaces which may not be required, okay, which are not mostly used, but we have to know them as part of our knowledge. We should have some knowledge, guys. Even though we don't use, let's say there is something like vector and stack. We generally don't use this vector and stack in our programs. Okay, they're legacy kind of things. Legacy means old ones. These are the latest ones. Arraylist and linked list are the latest, whereas vector and stack are the old ones. But still, we have to have some knowledge of vector and stack, guys. Okay, you don't. So anyhow, we'll be using Arraylist and linked list in real time. But vector and stack are the older concepts. Still, if you have some like a knowledge, that will be good, right? So in that perspective, what I will do is I will try to explain most of these interfaces and classes in the upcoming videos. Okay, I'll try not to skip most of these interfaces and classes. I'll try my level best in covering most of these interfaces and predefined classes of this collection framework, not only for usage purpose but also for the knowledge purpose. Okay, so guys, let's get started about this predefined classes and interfaces, detailed explanation of this different predefined classes and interfaces from the upcoming videos. For now, in this video session, I thought of explaining only about the high level collections framework and what are the different predefined classes and interfaces which actually comprise this collections framework in detail. I thought of, okay, which I covered it. The next video session, I'll explain the next topic, that is, in order to understand this collections framework better, we have to understand the difference between the arrays and collections. Okay, if you understand the difference between the arrays and collections, then you will be understanding the purpose of this collections framework in a better way. So this particular thing I'm going to explain in the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I am going to explain part 220 of Java for Tester series, that is collection interface. So what is collection interface? Collection interface is one of the root interfaces in the collections framework. Let me show you. So this is a collection framework, guys, collections framework. And as you can see, just below this collections framework, we have two different root interfaces. One is collection interface, another one is map interface. Okay. Under collection interface, we have several other child interfaces or classes. In a similar manner, under the map interface, it has its own child class and interfaces. So collection interface is one of the, okay, it's not the only, guys, it's the one of the, because there are other root interfaces also. Okay, under this collections framework, collection interface is not the only root interface, but also at the same time we have other interface like map interface, which is also a root interface of the collection framework, right? So that's why we are saying collections framework. Okay, under collections framework, we have several root interfaces, and this collection interface is one of the root interfaces of the collections framework. Okay, collection interface is one of the root interfaces of the collections framework. This is the first point we have to understand about this collection interface. So collection is an predefined interface which belongs to the collections framework and is also one of the root interfaces of the collections framework. And other root interfaces for this collections framework we have is map interface, okay, and other several other miscellaneous classes and interfaces also we have. So collection is one of the root interface of the collections framework. This is the first point. Second thing here is, what is the purpose? What is the purpose of this collection interface? So the purpose of this collection interface and its collection interface and its child interfaces and classes. Okay, I cannot say only the purpose of the collection interface. Instead, the complete group of the collection interface and its child interfaces and classes. Okay, what's their purpose? What's the purpose of this collection interface and its child classes and interfaces? The purpose of this collection interface and its child interfaces and classes is to group 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 different or to group individual objects as a single entity. Okay, so using this collection interface and its predefined classes and interfaces, we can group individual objects as a single entity, guys. Okay, so several individual objects can be grouped. Okay, let's say these are the different objects we have. Okay, and all these objects, object 1, object 2, object 3, object 4, object 5, object 6, can be grouped together into a single entity. This is a single entity, right? This is nothing but a single entity. All these different objects, individual objects, are grouped into a single entity with the help of collection interface and its predefined interfaces and child classes. Using all this collection interface and its predefined child classes and interfaces, we can group several individual objects as a single entity into a single entity. How to practically, okay, how to practically group these individual objects into a single entity? That thing I'll explain in the upcoming videos, guys. Okay, for now just understand this particular thing at a theoretical way, but in the upcoming videos I'm going to demonstrate how this collection interface and its predefined classes and interfaces can group individual objects as a single entity in a practical way. I'm going to explain in the upcoming videos. Okay, fine. Now you understood the purpose. Okay, now you understood the purpose of the collection interface and its predefined child classes and interfaces. Now, next thing we need to understand is the collection interface specific methods. Okay, collection interface has its own methods. Okay, collection interface comes with its own methods. So what are the different methods that I'm going to explain now? So before I show you the most commonly used methods of this collection interface, let's go to the Java API documentation. So simply search for Java 8 API or any other version of API, and you will get this Java API link. Click on that, and you will be taken to this API documentation of the Java. In this, Control F and search for collection interface. Okay, just press enter until you see this collection interface. As you can see, this is a collection interface which is in italic format. Is an interface, guys. So collection interface. Collection is an interface. Is a predefined interface in Java, which is one of the root interfaces of collections framework. One of the root interface of the collections framework. And this collection interface has several methods. Okay, predefined methods are also there. This collection interface comes with several predefined methods. As you can see here, these are all the different methods. All methods we have: add all, clear, contains all, equals, hash code. Like that, several methods are there. And we don't have to use all these methods. Okay, we don't have to learn all these methods of this collection interface, guys. Instead, you can learn these most commonly used methods of this collection interface. If you learn all these methods that are listed down here, that will be enough, guys. Okay, all these methods which are listed here also. Okay, add, here also add is there. Okay, something like that. So add is one of the method of the collection interface. Similarly, there are several other methods like add all, remove all, clear, retain all, is empty, size, contains all, toArray, and iterator. These are the several methods which belong to this collection interface. Okay, so how to use these methods, guys? How to use these methods of this collection interface? Can we create an object for an interface and use these methods? No, right? You cannot create an object for an interface. Let's try it out. Okay. Here collection is an interface in Java. As you already know, in Java, for interfaces, we cannot create objects. Okay. Without creating objects, we cannot call these methods, right? For interfaces in Java, for not only collection interface, for any interface in Java, we cannot create objects. If you try to do so, you'll get an compiler error that you cannot create object. But if you're not able to create an object for this collection interface, how can you call these methods? A lot of questions are there in our mind, right? So before that, let me practically demonstrate that you cannot create an object for an interface in Java, that too collection interface. So here we have sample program, we have sample main method too, and inside that I'm trying to create an object for the collection. Collection is a predefined interface. Collection C is equal to new collection. But here, using this new keyword, I'm trying to create an object for this collection interface. Okay. So first thing we have to do is we have to import this collection interface from the java.util package. Then only we can use. So this error got resolved, but there is one more error that is coming. When you hover the mouse, it says that this compiler error says that cannot instantiate. That means cannot create an object for this kind of collection interface. Okay. Objects cannot be created for the collection interface, guys. Okay. Objects cannot be created. If you're not able to create an object for the collection interface, then we cannot call these methods. We cannot call these methods. We cannot utilize these methods of the list collection interface because we are not able to create an object for the collection interface. But guys, in general, what we generally do is this collection interface here has many child interfaces and classes. As you're not able to create an object for the collection interface, we have to choose one child class of this collection interface. As you can see, one of the example here we have is Arraylist. Is a class case. For classes, we can create objects. This is a child class of the list interface, which is a child of the collection interface. So if you create an object for this Arraylist class, you can actually, okay, use the methods of this collection interface. We cannot directly use the methods of this collection interface as we cannot create objects for the interface in Java. So what we have to do, we have to choose one of the child classes of this collection interface, say Arraylist here, and using the object of that Arraylist, we can, since this is a child class of the collection interface, Arraylist will inherit the methods of this collection interface anyhow, right? So by creating an object for the Arraylist, the inherited methods from the collection interface can be utilized. This is how we have to use, guys, okay? This is how we can use the methods of the collection interface by creating an object for the child class of this collection interface, as child class of the collection interface can inherit all the methods of the collection interface. Here, one example of the child class of this collection interface is Arraylist, which inherits all the methods of the collection interface. This is a child class of the collection interface, so it inherits all the methods of the collection interface. Let's see Arraylist. Okay. So before that, let's go to the Java 8 API of the Arraylist also and see whether it has any methods in common with the collection interface. Okay. So Control F and search for Arraylist. Let's go to the methods. There are a few common methods also. You see, there are a lot of common methods. Anyhow, so let's choose one thing that is not there here. So something like iterator is there. Iterator is also common, and most of the methods are common, guys. Okay, so almost common methods. Okay, this is a collection. This is okay. Yeah, most of the methods are common. Okay, so in Arraylist also the same methods are getting repeated. That's fine, but guys, what we have to do here is if you have to still access the methods of the collection interface, we cannot create an object for the collection interface, guys. Collection C is equal to, I cannot say new collection like this, right? I want to use the methods of the collection interface, but I'm not able to create the object and use it. Instead of creating an object for the collection interface, I'll create an object for the Arraylist. Like this, new Arraylist. Hover the mouse and import. So here we have created an object for the Arraylist class and assigned the object to the variable of the collection interface. Now using this object reference, okay, which is storing the object of this, which is referring to the object of the Arraylist, but is of type collection interface type. Okay. Now you can say you can access, guys. You can access all these methods now. This is the only way, guys. You cannot directly access the methods of the collection interface directly. Instead, you have to create an object for the one of the child class of the collection interface and assign it to the variable of the collection interface. Then only you can use. Now, if I say c dot add, you see several methods we have is c dot add. I'm not going to demonstrate how to use these methods at this moment, guys. In the upcoming videos, I'm going to practically demonstrate all the methods of the collection interface. I'm going to practically demonstrate how they are going to work in the upcoming videos. For now, I'm going to show you these are the different predefined methods of the collection interface that its child classes will inherit. Okay, as we are not able to create an object for the collection interface, we can create an object for one of the child class of the collection interface and create a variable of that collection type. So using that object reference, you can use either you are able to access the add, guys, and then we have add all is also done. Then we have remove. You see, you are able to access now. Okay, because you are able to create an object reference at least. Remove all, remove all. Then we have something like clear. Then we have retain all dot retain. There is no other way, guys, to call this methods using the variable of the collection interface, as we cannot create objects for the collection interface directly. So we have iterator. Then toArray contains dot toArray. And we have contains all, contains and contains all. Then we have size and is empty. Set dot size dot is empty. Okay, like this. This is the only way, guys. Okay. So for now, you need to understand these are the different methods of which belong to this collection interface. And in order to use these methods, we have to create an object for one of the child class of this collection interface. And using the object reference of this, using the variable of this collection interface, we can access these methods. That is the only way. Okay. Fine. So guys, this is all about the collection interface and its predefined methods and its purpose. And in the next video session, I'll explain about the next interface, guys, that is list interface. The next interface we have is the list interface. As you can see here, under the collection interface, we have the one of the interface as list interface. There are three different interfaces under the collection interface. They are list, set, and queue. This is one of the child interface of the collection interface. This thing I am going to explain in detail in the next video, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 221 of Java for Tester series, that is list interface. So what is list interface? List interface is the child interface. List interface is the child interface of the collection interface of collections frameworks. Okay, in collections framework, this list interface is the child interface of the collection interface. Let me show you, guys. So here, this is a collections framework. Under that, we have this collection interface. Under that, we have the list interface. So here, list interface is the child interface of the collection interface, which is part of the collections framework. Okay. So what is list interface? It's the child interface of the collection interface of the collections framework. Okay. This is the first thing. So what is the purpose? What's the purpose of this list interface? The purpose is same, guys. Okay. The purpose of the list interface is same as the purpose of its parent interface, that is collection interface. Whatever the purpose of this collection interface is there, the same purpose the list interface has. Okay. In fact, the child classes of this list interface also has the same purpose. Okay. the purpose of the list interface is same as the purpose of the collection interface, which is a parent of the list interface, and also the purpose of this child classes of this list interface is also same as the purpose of this list interface. Fine. So what is the purpose of this list interface then, which is same as the collection interface? Is to group individual objects as a as a entity, as an entity, as a single entity, you can say. To group individual objects as a single entity. Okay. The purpose of the collection interface is also same. That is to group individual objects as a single entity. Let's say there's a box and we have different objects, object 1, object 2, object 3, object 4, object 5, object 6, object 7, like this. There are several objects. There are several individual objects. If you want to group all these objects into this single entity, okay, into this single entity, then we have to use this collection interface or its child interfaces and classes. Anything you can use, guys. Collection interface, its child interface is list, its child classes are array list, linked list, vector, stack. All these child interfaces and child classes of this collection interfaces, including the list interface, can be used. Okay, and the purpose of these things are to group individual objects as a single entity. Okay, like this, several objects can be grouped into a single entity. That's the purpose, guys. Fine. So next thing is, so how is this list interface different? Okay, list interface is a child interface of the collection interface, and the purpose is same as the collection interface. But how this list interface is different? Here, as you can see in this diagram, under collection interface we have list, set, and queue. Okay, list has some properties that set will not have, and set will have some properties that queue will not have, right? There will be some differentiation. Under collection itself, this list is specifically meant for something. What is that difference? What is that specific difference? How the list is different from the other child interfaces of the classes of the collection interface? Thing here is this list interface, the list interface and its child classes. Okay, this list interface and its child classes like array list, linked list, vector, stack uses a concept known as indexing. Okay, all this list interface and its child classes like array list, linked list, vector, stack uses this indexing concept, which is similar to arrays, guys. If you remember in one of the previous videos, I explained about arrays. Arrays use indexing concept for storing the values, right? At index 0, first element of the array will be stored. At index 1, second element of the array will be stored, like that. Similar way, the same indexing concept is followed by this list interface and its child classes. List interface and child classes and its child classes uses indexing concept for storing the elements or objects. Here everything is dealt about the objects, guys, right? Here objects, the purpose of the collection interface or list interface or its child classes or interface is to group individual objects as a single entity. Here focus is on objects, guys. Here we are going to use objects, group the objects. Okay, for grouping objects we have to go for this collection interface or list interface or its child classes. Fine. Here list interface and its child classes uses indexing concept for storing these objects. Okay, for storing these objects, similar to arrays where the values are stored with the indexing concept. Here in list interface and its child classes, we use indexing concept for storing these objects. Okay, storing the objects. So let's say how the indexing concept is used. Let's say array looks something like this, right? Okay, so here 0, here 1. These are the indexing, guys. Okay, the first box has the index 0, the second box has the index 1, third box index 2, fourth box index 3, and fifth box index 4. Okay, this kind of indexing concept will be used by this list interface and its child classes. Okay, fine. The first object one. Let's say you have given some strings. So let's say string is an object. So let's give some strings, guys. Let's say I'm giving some name like Arun. The first object got stored into the index 0. Okay. Second object, let's say Varun, is stored into the index 1. Third object, Tarun, is stored into the index value 2. Okay. Again, if I give Arun, will it take or not? Again, if I give Arun, will this will be considered or not? It will work fine, guys. Okay, it works fine because the reason here is duplicates are allowed, guys. Okay, because of this indexing, which is followed by this list interface and its child classes, here duplicate values are allowed. Duplicate objects, instead of values, you have to say objects, guys, because in collections framework, objects are stored rather than values. Okay, duplicate objects are allowed. So here again, second thing is I'm just giving some duplicate values here. Here Arun and Tarun are the duplicate values. Arun is already there at the index 0 and Tarun is already at the index 2. Here duplicate objects are allowed. Okay, why? Because indexing is there. The first Arun is mentioned with the index 0, whereas the second occurrence of the Arun is at the index 3. Since they are differentiated with this index, duplicate objects are allowed. That's one thing. Okay, list interface and its child classes allow the duplicate objects. Okay, duplicate all objects because of this, because how the duplicate objects can be allowed because of this indexing concept. Similar manner, the insertion order is preserved. Okay, insertion order is preserved. This is also possible because of the indexing, guys. Okay, insertion order is preserved. The first added object will be stored at the index 0. Okay, insertion is being done at the first index. The second inserted object is at the index 1. So here insertion, wherever you are inserting, that order is preserved. Arun, after that Varun, Tarun. When you print this value, this object stored into this list or its child classes, okay, they will be printed in the same order, in the way that you are inserted. Okay, because the first value stored at the index 0, second value stored at the index 1. Because of this indexing, when you retrieve all these values or objects, when you retrieve all these objects, they will be retrieved according to the insertion order. The way you inserted, the same order in which they will be printed, guys. The reason here is indexing. Because of this indexing being followed by this list interface and its child classes, the insertion order is preserved. Okay, duplicate objects are allowed and insertion order of these objects is preserved. Okay, even though you print, the way you inserted, the same way they will be printed. Okay, because the insertion order is saved or preserved in case of this list interface and its child classes. Fine. So these are the things, guys. Now, next thing is, now you understood what exactly the list interface, it is child interface of the collection interface. Second thing is, the purpose is same as the collection interface, to group individual objects as a single entity. And third thing is, it is different from other interfaces of the collection interface because of this indexing concept. Okay, list interface and its child classes follow the indexing concept. Because of this indexing, the duplicate objects are allowed, and also the order in which you have inserted these objects will be saved or preserved. The same way, when you retrieve, they will be printed in the same order. Okay, the same insertion order will be preserved and printed or retrieved. Fine. Next thing is, this list interface has its own methods. There are some methods specific to this list interface. Okay, there are some methods specific methods of this list interface. Let me show you. This list interface has some different methods. Most of these methods are related to the indexing only, guys. As you can see, you can add an object at a particular index. Okay, if you want to add a particular, if you want to add an object at a particular index, you have to use this add index comma object. But coming to the collection interface, which I explained in the previous video, we don't have that indexing method, guys. Add, only you have to provide the object here. Okay, you cannot decide the index here. A particular place at which you want to store the object is not possible in case of collection because this method doesn't have the indexing. But from list interface and its child classes onwards, you can use this method, guys. Okay, add of index comma object. At particular index, we can insert the object. Similarly, lot of methods are there like add all, index collection, remove index, index of, last index of, get index. You see, as you can see, most of these methods are specific to the index only. Index specific methods are there in the list interface, a set of index. And one more method, that is list iterator. Okay, list iterator belongs to this list interface itself. Here we have iterator method in collection interface, whereas in list iterator, in the list interface, we have this list iterator, which is similar to iterator, right? Here normal iterator, here we have list iterator. These are the most commonly used methods of this list interface, guys. Okay, so now the next thing here is not only the methods of this list interface. Okay, if you want to use the methods of this list interface, not only the methods specific to the list interface, but also the collection interface methods also will be used. Because why? Because the reason here is list interface is the child interface of the collection interface. That means the methods that belong to the collection interface will be inherited by the list interface. Apart from the methods specific to the list interface, okay, the methods of the collection interface will also be inherited by this list interface itself. So you can use both these methods and these methods when you work with the list interface. But there is a clause. The clause here is, in Java, you cannot create an object for the interfaces. Since the list is an interface here, still we cannot create an object. Let's see. Okay, let me practically show you. If I say list L is equal to new list, I try to create an object. Here new list I am saying. Hover the mouse on this list interface and import it from the java.util. Okay, util package. So even after importing also, I'm getting a compiler error saying hover the mouse. It says that cannot instantiate. That means you cannot create object for this kind of list. That means list is an interface in Java and you cannot create object for such kind of interface. Any interface in Java cannot be created with an object. Okay, you cannot create object for any interface in Java, guys. That's the reason we are getting the error. So then if you are not able to create the object, how you are going to access these methods which are specific to this list interface, or the methods which are inherited by this list interface from the collection interface, which is the parent interface of the list interface? The only way is that instead of creating an object for the list interface, Java allows you to create object for the child classes. Okay, so here let's say Arraylist is one of the child classes of this list interface. As you are not able to create an object for the list interface because it is an interface, what we can do is we can create an object for this Arraylist class and assign it to the variable of this list interface, then access all the methods of this list and collection interface. That is the only way, guys. Okay, here variable is declared with list interface type, but the object will be of one of the child classes of the list interface. That is Arraylist is one of the child class of this list interface. Hence you can create an object of this Arraylist class and assign it to the variable of the list interface type. Hover the mouse on this Arraylist and import this Arraylist class from the java.util package. Okay, now using this object reference L, now we can access all the methods. Okay, it can be the methods of this list interface or the inherited methods from the collection interface, all the things. You see, normal add is there, index with index adding of the object is there, like that. Okay, all the methods can be accessed now. Okay, as you're not able to create an object for the interface, you have to create an object for the child class of that interface and access the methods of that interface or its parent interfaces. Okay, so let's say list iterator is one specific method of the list interface. Let's see whether we can access that. L dot list iterator. You see, you are able to access. Similarly, you can access iterator method also. Okay, iterator method belongs to the collection interface. You can access that one also. Okay, this is only the way, guys. This is only the way for accessing the methods of the list interface or its parent interface inherited methods. Okay, by creating an object for the child class of the interface, we can access those methods. So this is all about the list interface, guys. The next video session, I'll explain about the first one of the first or one of the child classes of this list interface. As you can see here, Arraylist is one of the child classes of this list interface. This Arraylist I am going to explain. This Arraylist I am going to explain in the next video session in detail. And as you know that till now, maybe it may be collection interface or list interface was no, I didn't demonstrate. I didn't practically demonstrate all these individual methods of this collection interface or list interface, right? So in the next video session, along with explaining about this Arraylist predefined class, which is a child class of the list interface, I'll also practically demonstrate. All these predefined methods of this list interface and its parent collection interface. By creating an object for the Arraylist class, I'm going to practically demonstrate all the predefined methods of the collection interface and list interface as part of the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 222 of Java for Tester series, that is Arraylist class in detail. So I'm going to explain this Arraylist class in detail. In this video session, I'm going to explain this Arraylist class in detail. So what is this Arraylist class? Arraylist class is a predefined class in Java, guys. Arraylist class is a predefined class in Java, and it is a child class. Okay, child class of list interface. The child class of list interface, which belongs to a concept known as collections framework. So child class of the list interface of this collections framework in Java. So Arraylist is a predefined class in Java, and it is a child class of list interface of collections framework. Let me show you visually. Here you can see this is a collections framework in Java, and it has some interfaces at the root level, that is collection interface, map interface, and other miscellaneous interfaces and classes. So if you expand this collection interface, you got this list set and queue. And if you expand this list interface, you got this Arraylist class. As you can see, this is the Arraylist predefined class, whatever we are discussing about. Okay, whatever I am explaining about is this predefined class known as Arraylist predefined class. And it is a child class of which interface, guys? List interface. Okay, Arraylist predefined class is a child class of the list interface, and list interface is a child interface of the collection interface, which belongs to the collections framework. So what is Arraylist class? Arraylist class is a predefined class in Java, and it is a child class of list interface of the collections framework in Java. Okay, so fine. What is the purpose then? What is the purpose of using this Arraylist predefined class in Java? The purpose is same, guys. So the purpose of Arraylist predefined class is same as the purpose of the list interface and collection interface, which I've already covered in the previous videos. So let me explain again the same purpose. The purpose of this Arraylist class or its parent interfaces is same, that is to group individual objects, as a single entity. Okay, so in simple words, the purpose is to group the individual objects is the purpose. Okay, in simple words, the purpose is to group the individual objects. Let's say there are several objects like this: 1, 2, object 1, object 2, object 3, object 4, object 5, object 6, object 7, like this. And if you want to group all these objects as a single entity, then you can use Arraylist predefined class. Okay, not only Arraylist, guys, you can also use that list interface, collection. All those purposes same, to group the individual objects into a single entity like this. Okay, that is the purpose. So now let's move into the practical mode. Okay, let's start using this Arraylist class. As we have understood what exactly is this Arraylist class and what is the parent interface of this Arraylist and where actually this Arraylist class belongs to, and what exactly is the purpose of this Arraylist class. As we understood all those things, now let's move into the practical mode, where I'm going to show you how to create an object for this Arraylist class and how to use this Arraylist class for various purposes. Okay, various needs. So let me switch to the practical mode. So as you can see, this is a sample project having the sample class and sample main method. And inside this main method, I'm going to write the logic for this Arraylist class. So before actually I move ahead, what I have to do? I have to first create an object for the Arraylist class. Can I create an object for the Arraylist class, guys? Yes. All the classes in Java can be created an object. Okay. We can always create an object for the classes in Java without any problems. So let's create array list is a class name. I'll give the variable or reference name as list. I'll say, I'll first create an object now. New is a keyword which has to be used for creating the object. So new, which object I have to create? I have to create the object for the array list class itself. So new array list I have to say. That's it. Okay. So new array list will create an object for this array list predefined class and will be assigned to the list reference of this array list class itself. Okay. I have created an object for this array list class now. I'm getting some compiler errors. In order to solve them, I have to hover the mouse on this array list and select to import this array list predefined class from which package? Java.util package. Select this. The errors will go away. That's fine. Now, what next? I'm going to explain how to add objects into the array list. Okay. So guys, as the definition states, or the purpose states, the purpose is to group the individual objects. It's not values, guys. Okay. Complete collections framework works with the objects. It doesn't work with the values. Okay. So objects are required. Objects, it's not values. So guys, what I'm going to do is I'm going to add objects instead of values. I'm going to add objects into the array list using add method. There's a method known as add. As you already know, let's see the previous videos I explained, right? So we have this list interface and collection interface. So collection interface has this add method. Okay. Since this array list class, predefined class is inheriting or is a child class of this collection interface, right? Array list is a predefined class which is a child class of this list and collection interface. Okay, they are related. Array list is a grandchild, you can say, of the collection interface. If it is a grandchild, it inherits all the methods, predefined methods of this collection interface. So here, for collection interface, we have this collection interface has a method known as add method, which I already explained in the previous video. So we can use this add method with this array list object reference because array list is the child class of the or grandchild class of the collection interface. So let's try to use that list dot add, I am saying. Okay. Now let's provide some string objects. Let's provide some string objects, guys. So how to provide the strings? In the double quotes, you have to write something. Okay, let me give my name, Arun. Okay, then I will add another name, add of. Okay, add of. I will say Varun. Then I will say list dot add of. Another name I will give, say Tarun. Like this, I gave 3 string objects. I added 3 string objects using which method, guys? Add method. Add method belongs to the collection interface. Okay, since this array list class is inheriting the methods of this collection interface as it is child or grandchild class of the collection interface, we can use it with object reference. As you have created an object using the object reference, you have to call this method list.add and you have to provide the objects. Whatever the objects you want to add, you have to provide them in here. Okay, here I am providing the string objects. Fine. So next thing is I have added 3 objects. How many objects I added, guys? First object, second object, first object, second object, and third object. Now, after adding these 3 objects to this array list, added these 3 objects to this array list, I want to print them. I want to print this list and see whether these 3 objects have been added to this array list or not. How to print? System.out.println. In simple terms, you have to say system.out.println. Just print this object reference, guys. Okay. If the objects are really added to this array list, they will be printed in the output in a different format. something like this, guys. The format will be like square bracket, the first object, comma, the second object. This will be the output. If these three objects have been really added to this array list, they will be printed like this when you print the object reference of this array list. Okay. After adding the objects, if you print the object reference of the array list, they have to be printed like this if they are really added. Okay, this should be the output, guys. Okay, this should be the output. I just commented. I'll remove it again. Okay. So it will be something like this. Arun, comma, Varun, comma. It will be like this, guys. Okay, it will be like this. Arun, Varun, Tarun. It should be like this. Let's see. I'll remove this and I'll run this code to see whether we are getting the proper output. Right click, run as Java application. As you can see, whatever the output I mentioned, that is Arun, Varun, Tarun, inside the starting and closing square brackets separated by these commas will be printed like this. Okay. When you print the object reference of the array list, if there are any objects already added to this array list, they will be printed in this format. Next. So you have to remember, guys, you have to remember these methods. Okay. I'm going to explain a lot of methods one by one. Okay. There are several methods. As you can see, this collection interface has several methods and this list interface has several methods. All these methods are inherited by this Arraylist predefined class. Okay, because Arraylist is a child class of this list and collection. Most the methods which belong to the collection interface, list interface can be inherited and used by this Arraylist class. I'm going to demonstrate all these methods. Okay, with Arraylist class, how to use them and all. The first method I already demonstrated is this add method, guys. Okay, so we can say using add method for adding the objects into the array list. Okay, this is what I did using the add method. Fine. Add of object. You have to. This is object, guys. This is object. Add of object. Add of object. Add of another object like this. Three objects. Then we printed it. Now the next thing I am going to explain is, so since we added it and printed it, I'm going to remove the print now. I'm not going to use the print. Now I want to retrieve, guys. Okay. This method is for adding, guys. Okay. Add method is for adding the objects to the array list. Now I am going to retrieve. Okay. Retrieve the objects from this array list. For that, we have to use a method known as get method. Or yeah, get method we have to use. So get of some index, using get of index method for retrieving the objects from the array list. From the array list, I'm going to retrieve the values which are available at a provided index. Let's say if I provide some index. Okay, so how to use this method, how to call this method is using the object reference in the same way. How did I use the add method? By using the object reference of this array list, I have to say object reference dot add. Okay, similarly, I have to use the object reference list dot get. I have to say, when I say get, it's asking for the index, guys. Okay, it's asking for the index. So this one is at 0th index. This one is at first index. This one is at second index. So before I explain this part, okay, let me explain about the indexing here. Okay, I didn't cover the indexing part. So when I say list.add Arun, what will happen internally is, okay, let's say, so this will happen, guys. Okay, let's say this is an array. It looks like similar to an array. Okay, array list, but it's an array list. So into the first, okay, index 0. This is index 0, guys. At index 0, when you say list.add, this object will be added to which index? First index, that is 0th index. So here Arun will be added. Okay. Again, when you say list.add of Varun, okay, this object will be added at the next index, that is index 1. Okay. At index 1, what will be added? The second object will be added. Similar to arrays, guys. It looks very similar to arrays. And at the second index, okay, 0th index, first index, second index. Okay. Third object, list.add, that is Tarun object will be added. Like this. This will happen internally. So array list and its parent interface, that is list interface, array list class and its parent interface, list interface, okay, uses a concept known as indexing. Okay, they run on indexing. Array list runs on indexing similar to arrays. Array list uses indexing for storing the values. At first index of at the 0th index, the first object will be stored. At the first index, the second object will be stored. The second index, the third object will be stored like that. Okay, similar to arrays, but here objects are being stored at the provided indexes. Fine. So now guys, now we understood that array list uses indexing concept for storing the objects. Okay, at the appropriate indexes. Fine. Now I'm going to use this get of index method, okay, for retrieving the objects from the array list. Now if I say list dot get off, let me type again, list dot get off index if I provide, okay. If I provide an index as 1, which value will be retrieved, guys? Here at 0th index, first object got stored. At first index, the second object, that is Varun, got stored. So when I say get off 1, okay, get off 1, which value will be which object will be retrieved? That's nothing but this Varun object will be retrieved, right? This will return you the Varun object. The return type is object, guys. You see, when I hover the mouse on this method, it says that this get method is going to return your object, okay, not string. It's going to return these are all objects, guys. Object one, these are not, they look like strings, but these are objects, string objects, okay. So they are actually treated as objects by this array list. Even though you provided them in the double quotes, all these three things are being treated as object. As you can see, the return type is object class. Object class. So what I will do is obj I will say is equal to, when I say obj is equal to list dot get of 1, okay, whatever the object that is there at the index 1, that is Varun object, will be returned and stored into this variable. But what is the return type? I have to give the return type for this variable, right? I have to declare this variable. To use this variable, I have to declare it. So simply hover the mouse and select create local variable. Automatically, the return type of this method will be added here. Object obj is equal to list dot get of 1. Now if I say system dot out dot println, if I say object, if I print this object, what will be printed, guys? This Varun object will be printed. Okay, you have to understand that the return type of this get method is object in this case. It's an object. Okay, right click, run as Java application. You see, the Varun object got printed. You don't have to provide all these things, guys. Simply you can say system.out.println like this also. Okay, list dot get of 1. I can directly say like this. This get method will return you the object. That object will be printed by this print statement. Okay. So instead of explaining directly with the print statement, why did I explain in a previous way? Is like I just wanted to show the return type. Okay, the object is the return type. In this case, the objects are being stored. Okay, add is storing this Arun string looking like text as an object. Okay, Varun also is getting stored as an object. Tarun is also getting stored as an object, not strings. Okay, that's the reason I explained the return type there. Now, as you have already understood the return type of this objects, okay, return type objects. Now I'm going to explain the println statement. Okay, directly you can use this println statement like this. List dot get of 1, system.out.println, you can directly say list dot get of 0. Okay, what will be printed, guys? Which object will be printed? 0th index, Arun will be printed. Arun object will be printed. List dot get of 2. Which object will be printed? 0th index, first index, second index. That is Tarun object will be printed. So let's run this. Right click, run as Java application. See, at the index 1, Varun object. Okay, at the index 0, Arun object. At the index 2, Tarun object got printed. Okay. So this is how we have to use the get method with the index value of that object to retrieve the objects from the array list. Okay, it will return you the object. Okay, it will return you the object. The get method will return the object. Fine. Now guys, so far so good. Now what I want to do is, I want to retrieve I want to find out the size of this array list. I want to find the size of the array list. So how to find the size of this array list? How many objects I added, guys? 1, 2, 3. What is the size of the array list? 3. Okay, you can directly say, by looking at the code, you can directly say that there are 3 objects added to the array list, so the size is 3. So without you manually counting and saying the size, if you want to programmatically achieve or get the size using some predefined method, if you want to get the size of this array list, then we have to use a method known as size method. Okay, using size method for, okay, finding the size of the array list. Using the size method, okay, we have to do this. So earlier I explained about one of the method, that is this where is that, get index method. This is also covered, right? Initially I covered add method for adding the objects into the array list, and for retrieving the objects from the array list using their index values, I have explained get of index. Okay, this method also I explained already. Now the third method I am explaining is this size method, which belongs to the collection interface. Using this size method, we can find the size of the array list. Okay, we can get the size of the array list. So how to do that? So whose size you want to find this particular array list? We have to take this object reference again, that is list. You have to say dot and access the method known as size method. Okay, this will return you the size. You see, int data type is there. So simply, what you will do is system.out.println, you can say, and say list dot size. Okay, this size method will return the size in the integer format. That int value will be printed by this print statement. So what should be the output, guys? The output should be 3, because here 3 objects are there. So size of the array list is 3. So the size method should return you 3. Right click, run as Java application. You see, 3 is the output. So what is the method for finding the size of the array list? Size method. Fine. Next thing I would like to demonstrate is, I would like to use for loop with this array list. Why I have to use for loop with this array list? I want to iterate. Okay, using the for loop, I want to iterate through all these objects one after the another one and print them. Okay, let's say. So I would like to use for loop here. What is the syntax of for loop, guys? For int I is equal to 0, I less than the size of the array list. How to find the size of the array list? Already explained, right? List dot size, I have to say. This size will return you the size of the array list. Put a semicolon and I plus plus. Okay, I is equal to 0, I less than list dot size, then I plus plus, I have to say. Inside this for loop, I have to write the print statement saying system.out.println list dot get of, what's the method for retrieving the objects from the array list? Get method, right? I'm using the get method. Get of index value I have to provide. So instead of providing the index value here, I'll provide this variable I. So how this program will work? How this for loop will iterate through this array list objects and how it will retrieve the objects? Let me explain. So till here it is clear, right? We have created an object for the array list, and using the object reference, we have added 3 objects here: Arun, Varun, Tarun. Okay, 3 objects have been added. Now, when the turn comes to the for loop, first the variable I will be initialized with the value 0. Okay, I is 0 here. The current value of I is 0. After the variable I is initialized with 0, then the next thing that will be executed is this particular condition, that is I less than list dot size. 0, I is current value of I is 0, guys. Okay, 0 less than list dot size. What is the list dot size, guys? 3. We already know it is 3. So 0 less than 3. True or false? It's true. 0 is less than 3 is true. Okay. So this is a condition that's being verified. 0 is less than 3 is true. So since the condition is true, we'll go inside the for loop, and this print statement will be executed, and list dot get of current value of I is 0 only. Get of 0. What is get of 0, guys? Arun. Arun object will be printed. First Arun object will be printed. Then again the control will go to the I plus plus. The value of I will become from 0 to 1. Now the condition will be verified. That is 1 less than the size 3. Again true. 1 is less than 3 is true. It will go inside the for loop. Here list dot get of current value of I is 1. Get of 1. Get of 1 means this index value 1, the object is Varun object. So Varun object will be printed this time. Next, again I plus plus. I will become 2. 2 less than 3 is again true. It will go inside. List dot get of 2. List dot get of 2 is index 2 is Tarun object. Tarun object will be printed. After Tarun object got printed, I plus plus will happen. I will become 3. 3 less than 3 is false. So it will come out of the for loop. This is how this for loop will work, and it will iterate through all the objects of this array list, and it will retrieve using this get method. Okay. So right click, run as Java application. You see, first Arun got printed, Arun object. Then the second iteration, Varun got printed, Varun object got printed, and the third iteration of the for loop, Tarun object got printed. This is how we have to use for loop with this array list, guys. Okay, we have to use this for loop with this array list. Now that's fine. Now let's use another type of loop, that is for each loop. Okay, for each loop can only be used with arrays and collections. For each loop can only be used with arrays and collections. Okay, other than this arrays and collections, you cannot use for each loop anywhere. Okay, collections framework, you can say all the predefined classes and interface in the collections framework, you can use this for each loop with. Okay, using this for each loop can only be used with arrays and this predefined classes and interfaces of this collections framework. Since array list is one of the predefined class of the collections framework, okay, let's use this for each loop with this array list. The similar way we use with arrays. Okay, so how to do that? Let's write down the syntax for the for each loop for iterating through all the objects that are already added into this array list and retrieving them and printing it. Okay, printing them. So here, what is the return type of okay? Here each and every addition is an object, guys. Okay, so the return type of the get is also an object. So generally object you have to say. Okay, object, since each and every item here is an object. So object temp colon this array list you have to provide. This is how you have to use the array for each loop. Okay, so list has a group of objects. This particular array list has a group of objects. So this for each loop will take each and every object one after the another and assign to the this temp variable, which is of which type? Object type. Why I'm saying object guys? Because if I say here each and everything is an object, guys, it looks like a string, but it's an object. I already explained, right? If I say get of one or something, it is returning you an object. So each and every item or element here is an object. Okay, so temp is an object. Out of this complete list, the first item, that is Arun object, will be assigned to this temp. Now system.out.println, I will explain you how this will work. Okay, so when the for each loop starts executing, object temp list, this statement will check whether there are any objects available in this array list. If there are any objects, yes, there are 3 objects here. So what this list will do is it will assign the first object to this temp of the object type, that is object. Okay, and when you say system.out.println, now let's say temp. The first iteration which this list has assigned which object? First object, that is Arun, has been assigned here. So Arun will be printed in the temp. Arun will be stored. So Arun will be printed first. Then again the control will go here, and this particular thing will check whether there are any other objects. Yes, there are 2 more objects. So out of these 2 more objects, the first object, that is Varun object, will be assigned to the temp. Okay, and since there is an object, we'll go inside the for each loop, and this time temp will print the Varun object. Again, the control will go to the list, and this list will verify any other elements or any other objects left in the array list. Yes, there is one more element or object, so it will assign that object to this temp of this object type. And since there is an object available in the list, okay, pending objects available in the list, we'll go inside the for each loop, and this temp will print the last object, that is Tarun object. Again, the control will go to the list, and after 3 objects, are there any other objects? No. Since there are no other objects, will come out of this for each loop. Okay, this is how the for each loop is going to work, guys. Okay, don't get confused and keep string here. This will not work. Okay, you have to keep object, because here all these 3 things are objects, not strings. Okay, for object temp colon list, You have to say something like this. Okay. So this will work in the similar way of the for each loop, which I already demonstrated just before. Okay. When I run this, you see Arun, Varun, Tarun got printed. So this is how, guys, we have to use for each loop with the array list. Fine. That's great. So now there are a few more things you need to understand, or you have to know about this array list. Thing is, duplicates are allowed, guys. Okay. Array list will allow you to add the duplicates. The reason here is because of the indexing concept. Okay. Since the array list follows this indexing concept, okay, as you can see, all these objects can be separated or differentiated with the help of these different indexes. Okay. Even though you have some duplicate object here, already Arun is there here. Again, if you have another Arun here, let's say, okay, but index is going to be different. This index is going to, first Arun index is going to be 0, but this Arun index is going to be 3. Since this Arun and this Arun object are both are same, but they can be differentiated with the help of these indexes like 0 and 3. That's why array list allows you to add duplicate objects. Okay, let me practically show you. So if I say list dot add of, already Arun is there, but if I try to add the Arun again, Arun object again, this will not result in any error. Okay, as this Arun object, the other that duplicate Arun object will be added at index 3 as shown in this image. Okay, so you see you didn't get any issues. Even if you print out, if I print out this array list like this, the duplicate objects will also be printed. Okay, they are considered because both these duplicate objects are at different indexes, 0th index and 3rd index. You see Arun, Varun, Tarun, you can add duplicate objects and get them printed. Okay, so duplicate objects are allowed is the statement. Second thing is insertion order is preserved. Okay, so when I printed this array list, have all these objects have been printed in the same order in which I have inserted using the add method. Okay, when I printed this array list, I have all these objects have been printed in the output the same way, the same order of the addition or insertion. Yes, the answer is yes. Insertion, because insertion order is preserved. Okay, insertion order is preserved in case of array list. Okay, so index 0, index 1, index 2, index 3. When you print it, the same order. First Arun should be printed, then Varun, then Tarun, Arun. Okay, first Arun got added. So when you print it also, first Arun should be printed. So same order in which the insertion happened, the same order it should be printed. This proves that the insertion order is preserved in array list. Okay, let me run this. Already I ran this and let me run it again. As you can see, first Arun is there because Arun is inserted first, so Arun is there. Second, Varun is there because Varun is inserted second. Then we have Tarun because Tarun is inserted third place. And again, Arun has been inserted at the fourth place. So the insertion order is preserved. If you are getting a different output, like first you are getting Varun, then Arun, then Tarun, something like that, then that means insertion order is not preserved. But in the case of array list, whatever the order you add this object, the same order they will be retrieved. Okay, when you print them, the same order they will be retrieved and printed. That's the reason we can say insertion order is preserved in case of array list. And this is also happening because of this indexes case. Okay, because of this indexing concept itself. Okay, because of this indexing only, these objects which are inserted in this particular order are getting retrieved in the same order, because first 0th index object will be retrieved, then first index object will be retrieved, then second index object will be retrieved, then third index object will be retrieved. Okay, that's the reason insertion order is preserved in case of array list, because of indexing only. Third thing is, another thing about this array list, null insertion is allowed. Okay, for suppose you don't want to add any object. Okay, but you want to add something, but you don't want to add any object. Arun, Varun, Tarun, or Arun, all these are objects, real objects. But if you don't want to add anything, you can add null. Null means nothing, no object. Okay, is this allowed, guys? Yes, this is allowed in case of array list case. Okay, you can add null, nothing. You can add nothing in case. Okay, at the index 4 null, that is no object will be added. Okay, it's kind of blank or nothing, you can say. Null insertion is allowed in case of array list. At the index 4, this null insertion is allowed. There is nothing. No, if you don't want to add anything, you can add null. Okay, that's what actually null is about. When I run this, you see null will be printed in the output. In the output itself, Arun, Varun, Tarun, duplicate value of Arun, then null. Okay, null means nothing. So next thing. So far I showed you how to add the objects, right? I showed you how to add the objects. Can we remove the objects? Is there any method using which we can remove the objects in the array list? Yes. If you go to this collection interface, there is a method known as remove method using which, okay, using which we can remove the objects. Okay, we can remove the objects. Fine. Let me show you. Okay, so this collection interface has this remove method of collection interface I am going to demonstrate, guys. As you can see, list interface also has another method called remove, which has an index, which I will be explaining later. But for now, without index itself, we can remove. Okay, how to remove the objects without index? Directly we can remove. So instead of avoiding this confusion, I'll just keep this Arun, Varun, Tarun, 3 objects. Okay. Now after this, if I print directly, what will be print output, guys? If I print like this, 3 objects added, and when I print the array list here, these 3 objects will be printed, right? Right click, run as Java application. The 3 objects will be printed. Arun, Varun, Tarun got printed. But before printing this, if I say list dot remove of object, okay, remove of object. Let's say I want to remove an object known as Varun. After adding these 3 objects, I am using which method? Using remove method for removing the objects from the array list. Okay. So for removing the objects from the array list, I am going to use which method? Remove. Remove of object have to provide. This is remove of object method. Here object is Varun object. So list dot remove the object known as Varun. So which is available at index 1. This will get removed, guys. Okay. The object at the index 1 will be removed. So when I print this array list, what will be printed, guys? Out of 3 objects, we have removed this Varun object. So the remaining 2 objects, that is Arun and Tarun, will be there. Those 2 should be printed. Okay. Earlier when I ran this program, there are 3 objects printed. But now, as I am removing the Varun object, without this Varun object, Arun and Tarun will be printed, guys. Okay. That proves that using the remove method, we are able to remove the object, specified object. Okay. You see Arun, Tarun. That means Varun object got removed. Fine. So we are able to add, we are able to print, we are able to retrieve the objects, right? And we are also able to remove the objects. Okay, remove the objects from the array list also with the help of the methods. Using which method we removed it? Using remove of object method we removed it. Okay. The next thing is array list is a resizable array, guys. Okay, array list is a resizable array. Why I'm saying array list is a resizable array? Let me explain. So in order to understand the statement, that is array list is a resizable array. In the previous videos, in one of the previous videos, I explained about the array concept, right? Before this collection framework started, okay? In the same video series, I explained about this array. Now I'm explaining about this array list, okay? And I'm saying that array list is a resizable array. What does this resizable mean? Either you can increase the size or you can decrease the size. Okay, either you can increase the size or decrease the size. Let me compare this. Okay, let me compare. Let's say this side we have array. Okay, and this side we have array list. So as you already know, arrays are fixed in size. Arrays are fixed in size, whereas array list is resizable. Okay, either you can grow the size or reduce the size. Both you can do. Okay, how to grow the size? Using the add method. Okay, how to reduce the size? You can using remove method. There are 2 methods, right? The array list. One is for adding or increasing the size of the array list dynamically, or wherever you want to increase the size, you can increase using the add by adding the different objects wherever you want. There is no limit, right? That's why it's not fixed. They're resizable. It's non-fixed. You can say non-fixed in size. Okay, they can keep on growing and they can keep on reducing in size. Okay, that's why array list is non-fixed. As coming to the arrays, they are fixed in size, guys. Okay, let me take out this part and let's explain you the arrays. Okay, let me show you array. Array A is equal to, if I create an object for an array, so sorry, there's some mistake. Integer array A is equal to new integer array. I have to give some size, guys. Here I have to give some size. So let's say I give the size as 3. Okay, or else I'll give it a string, guys. String array I'll give. Okay, so that I can make it relevant. If I say A of 0 is equal to Arun, okay, A of 0 is equal to Arun, this is accepted because the size of this string array is 3. So how many values I can store? 3 values. This is at index 0. The first value stored at the index 0. The second at the first index. Second value can be stored, that is Varun, which is at index 1. So how, 2 elements are done. So size is 3 here. So one more element, that is A of 2 at index 0. That is Tarun. Like this, Tarun I can say. Okay. At index 2, like this. Okay. So three what you can say, 3 array elements can be added. But if I try to, okay, if I say system.out.println, okay, I'll say I'll use some for loop, guys. For int I is equal to 0, I less than a dot length. In case of arrays, length is a predefined variable which will give the size of the array, right? As I already explained in the previous videos. I plus plus system.out.println a of I. If I say a of I, what will be printed, guys? So without any problem, all these 3 values which are assigned to this array of size 3 will be printed. Here 3 values are assigned. Only 3 elements are allowed. So no problem. Right click, run as Java application. But what if I try to add another value or another element into the array? Okay, let's try to add something like Motori here at index 3. So how many values I added? Okay, how many values I assigned to the array? 4 values. But how many are allowed? Only 3. Arrays are fixed in size. Here 3 is the size of the array. Size of the array is 3. Once you create something here, you cannot add more than that. Here 4 values are not allowed. Only 3 values are allowed. Right? 3 elements are allowed. 4th element are not allowed. Am I getting any compiler error? No. But when I run this program, I'm going to get an exception saying array index out of bounds exception. The size is 3. The size of the array is fixed, but you are providing 4, which is not possible. Okay. At the line 10, that is at the place where you are adding the 4th element of the array of size 3 is giving you the exception. Okay. But guys, this is all about the arrays. Arrays are fixed in size, but coming to the array list, they are not fixed in size. Okay. Array list is equal to new array list. I write something like this and import this array list class from the java.util. Now, is there any size I mentioned here, guys? In this statement, did I mention any size? Non-fixed. Okay. In case of arrays, I have to mention the size. Non-fixed size. This means that I can keep on adding. List dot add. I can say Arun. No issues. List dot add. Can say Varun. No problem. Then list dot add. Then I'm giving something like Tarun. Okay. Now list dot add. Giving another value Motori or something. Okay. If I say system.out.println list and run this, right click, run as Java application. You see, no problem. There is no fixed size, guys. Okay, they can grow in size, they can reduce in size. That's why I'm saying they're non-fixed size. They can increase like anything, they can decrease in like anything. I can remove also. Okay, if I want to remove Motori here, I can remove. I want to print this after remove. Okay, when I run this, you see, it will be reduced. The size of the array list can be reduced. Okay, there is no fixed size, guys. So that's why we can say array list, arrays are fixed in size, whereas array list is resizable, non-fixed in size. They can either grow or reduce in size. Okay, without any fixation problem. Fine. Next thing about the array list is we can by default add heterogeneous objects. Okay, homogeneous means here in so far in this example I have given homogeneous objects only. These are all homogeneous because there are string type objects, right? Arun, Varun, Tarun, Motori. Okay, all are string type. But guys, by default in array list you can add which type of objects? Heterogeneous objects. So in the as the first object you can add Arun, which is a string object. That's fine. This dot add. I can give some integer object here. This is an integer object, guys. It's not an integer value. It's an integer object. Okay. This dot add some double object or some decimal object. You can say whatever you can say. Okay. List dot add some boolean object. I can add. I can add the character object. Let's say yes. Like this, guys. It's heterogeneous. By default, array list is heterogeneous type. Okay. These are all objects. This is object 1, object 2, object 3, object 4, object 5. Okay, of different. They are object types, and you can by default you can add the heterogeneous objects. Different types of objects you can add at a go. System.order println. If I say list, and if I run this, it will run without any problems. You see, all the heterogeneous objects got printed here. Objects of different types got printed here. But in case of arrays, guys, by default they are not heterogeneous. If I say int a is equal to new int of, okay, or int a is equal to 3, 5, 6. Okay. If I try to add something like Arun or something here, it will give you some compiler error saying that type mismatch. This is not possible until and unless you make this array in object class type. Okay. Instead of primitive data types, if you provide this array with object, by default they are not heterogeneous, they are homogeneous. But if you make this object class type, array as object class type, then only it is possible, guys. Okay. Now we can add. In case of arrays also, you can add heterogeneous values. Okay, by making this array type as object class type, because object is a parent class of all the classes in Java. So it will allow you to add different type of values. So, but in case of array lists or any other collections frameworks, predefined classes and interfaces, they are heterogeneous by default. Okay, by default they are heterogeneous, guys. Okay, here we have to manually go to the object class type to make this arrays as heterogeneous. But coming to the array list, they are by default heterogeneous. Array list is equal to new array list. I'm not doing anything. I'm not specifying any object class or anything here. Okay, I'm simply creating an object for the array list. And when I try to add the heterogeneous object types like this, okay, it's allowing you. That means by default the array list or any other collection framework predefined classes and interfaces are which type? Heterogeneous type. Okay. Arun Varun dot add. So if I give here 9 or something, it will work. If I give some Boolean value also, it will work. Okay, as I already shown you. So array list is by default heterogeneous. Compared to arrays, by default array list is heterogeneous type. Fine. Next thing. What if I thought of having only string object types? Okay. I thought like the user will input only the string objects. Okay. I thought like the user will add only the string objects into this array list. I thought like say array list names. Okay, let's say array list names is there is equal to new array list. If I say names dot add, I was expecting from the user, like blindly expecting from the user that Arun can be added. Names dot add. Things are going well. Varun has been added. This is also a name, so not a string name. That's not a problem. Names dot add of Arun, if I'm saying this is also not a problem. Okay, so far so good. But when I said add of 9, this is something, this is accepting, this program is accepting, but here the context of the program is that only the names or string objects have to be added. But here I got an unexpected input because I didn't mention this is not strict, right? By default they are heterogeneous. Already explained, by default the array lists are heterogeneous objects. Okay, any type of objects, it can be string objects or integer objects or character or boolean objects can be accepted here. But as per this program, I was expecting only the string objects because it's the names. The name of this array list is names. Okay, I thought like this cannot be added. That is not correct, guys. But still, if you want to add such kind of rules where only the string objects have to be added here, what can you do? Okay, how you can change the program? If the user tries to add some integer object in place of the string object in this case of program, okay, I want to give a compiler error. How to do that? How to do that? The answer here is, okay, we can specify the wrapper classes, strings, and objects as generics. There is a concept known as generics, guys. Okay, there's a concept known as generics. In Java, there is a concept known as generics. In this video, I'm not going to explain generics in detail, but to the context, I'm going to explain. To how much you need to understand the generics part, I'm going to explain anyhow. But the complete details about the generics will be explained in the upcoming videos, where I'll be taking good number of videos on generics in a detailed manner. Okay, but for now, coming to this collections frameworks and the predefined classes, how to use the generics here. Here, after the array list, we have to provide a generic. Generics will start with this less than symbol and greater than symbol. Okay, and in between this less than and greater than symbol, you have to add. Here I can add string, guys. Okay, I'm expecting all these objects to be string type, string class type. String is a class, so objects exist for this string. String is a predefined class in Java, so it can be allowed, guys. Okay, inside this less than and greater than symbol, I just added string. So, and the same thing I need to add its array list also. Okay, object creation statement also. You see, earlier we got some warning symbols. If I remove this, you'll see after adding the generics, the warning symbols will be gone away. So before adding the generics to this statement, object creation statement of this array list, as you can see, some yellow warnings have been displayed. Okay, raw type, that means any type, object type you can say. So references to generic type E should be parameterized. You can parameterize the generics here. That means you want only the string objects to be added into this array list. I can simply provide inside this generics, I can provide string. Only the string objects can be assigned. So the same thing, I have to put it here. You see, warning is still there here until I add the generic. That after I add the generic, it will go away. You see, now there are no warnings in this statement. There are no warnings. Yellow colored warnings have been gone away. Okay, warnings are like they are not errors, guys. So you can actually still continue. Okay, but guys, the moment I added this string class type generic beside this array list class names in this object creation statement on the both sides, right? New array list string is there, array list string of names is also there. Okay, declaration side also this generic has been provided with this array list class name, and on the object creation side also this generic name has been provided with the array list class name. Fine. Now in such kind of cases, this array list will only accept the string objects. Other than that, if you try to provide anything, it will give you the compiler. You see already you got a compiler error here. Names dot add of 9. This 9 is an integer object, but here this array list is expecting only string type object. 9 is not a string type object, so you are getting compiler error saying that, okay, int. It is an int type, it's saying. So what if you try to add another type of object like boolean, let's say true, still you are going to get the compiler error. Okay, 9 or true or this, because incompatible type. Okay, incompatible object types 3.56, still you are going to get some character value, say yes. Okay, still you are going to get. But if you provide something like string object here, it will not be coming. The compiler error will go away. Okay, so if you say string here on both sides of this object creation statement, then only string objects are allowed. Okay, only the string objects are allowed. Now, if I say names dot get off someone, okay, names dot get off one, what will be the return type, guys? You see string here. Earlier, when I didn't specify the generics here, I got the return type of this get method as object class. But this time it's directly giving the string class. Okay, so a is equal to string. String a is equal to names dot get of I one. Okay, I can directly print a. So right click run as Java application. Earlier the get method used to return without generics. The get method used to return the object class. But now the get method is returning you the string class. The return type of this variable is going to be the string. Okay, return type of this method is going to be string. So the variable a should be declared with string object. Okay, string class type. So the output has been printed. Varun. Okay, Varun got printed. Fine. Now I don't want strings. Okay, I want to write this program again. Arraylist list is equal to new Arraylist. This time I will say age. Okay, I'm just taking some random things. Okay, Arraylist age. Generally age will be in numbers, right? So fine. So if I say age dot add of Arun, is this correct? Wrong, right? This is not correct. Okay, I cannot add some strings here. String objects I cannot add because to the context it is age. Age should be in numbers. Okay, but still it is allowing. So here if I say integer, okay, and add the same thing to avoid this warning message here on the both sides of this object creation statement. What is this integer, guys? Integer is a wrapper class. Okay, so if you want to add some integer values, you have to provide the wrapper classes of that particular type values. Age dot add of, okay, 30. Fine, age dot add of 30. Age dot add of 25. Age dot add of 60. Like this. Okay. But if you try to add something like age dot add of some Tarun, you are going to get a compiler error because here into this array list only you can add the integer objects. In order to store the integer objects, the integer objects can be stored into the integer wrapper class. If they are values, they can be stored into the int primitive data type. But here, these are all objects, guys. We have to provide the wrapper class only. Okay, here wrapper class only is allowed. Okay, and also if you try to add different type of objects here other than integer objects, if you try to provide any other objects, it will give you a compiler error. Okay, so integer is a wrapper class. We have different wrapper classes, right? We have double. The moment you specify double here, you see you are going to get a compiler error for all these statements because when you say 30.56, the compiler error will go away because double objects are being added. 325.12, 60 point some 60.37. Okay. Now here again 12 point some 35. Okay. So double. If you say boolean here, boolean, if you provide boolean wrapper class here, all the generics I'm providing the wrapper classes, guys. Okay, based on the type of the objects I have to add, I have to provide the wrapper classes, respective wrapper classes. So here if I say boolean, I have to give true. To overcome this compiler errors, I have to give boolean values, boolean objects, that is true, false, false, then true. Okay, like this. So what if I have this character wrapper class here? Character. It will not accept the boolean objects. It has to accept only the okay, O some n. Okay, character objects have been accepted here. So like this, guys, you can use inside this generics of this array list based on the type of the objects you want to restrict. You have to provide such kind of wrapper class, respective wrapper class you have to provide. Okay. So what if I want to add all, okay, heterogeneous objects? Simply you remove this generics. There is no need of generics, right? There's no need of, if you remove this generics, you can add any type of object here. I can say some list, I will say here, list dot add of, I can add any type of object here. I can add some Arun, list dot add some integer object, I will add 9, some decimal object, double object, you can say 3.56. This dot add some true, list dot add some character value, character object, you can say. Okay, like this you can add different type of objects, heterogeneous objects. But as you can see, you are getting some warning messages for each and every statement you have written here. It will work, guys. Despite of these warning statements, it will work. When I say list and then print it, it will work without any problem. The program will run. You will get the heterogeneous output, objects output. But guys, still you want to overcome this warning messages, simply still you can provide generics by giving something like object. Object is a parent class of all the classes in Java. Okay, so any type of object can be stored into this kind of array list, which is specified with this object generic class type. Okay, and also you're not getting any warning messages. Okay, without this generics, you are going to get the warning messages. And once you add this object class type into the generic type of this array list, you are seeing that there are no warning messages. Okay, and the program will also run properly. Right click, run as Java application. So into this array list, what type of generics you can provide, guys? You can either provide string, you can either provide here string, or you can provide here some wrapper classes like integer, double, okay, etc. Or you can provide object class type. Okay, only the classes, class names you can provide, guys. Other than wrapper classes or string class or object class, you have to provide. But you cannot provide. But you cannot provide primitive data types. Okay, you cannot provide primitive data types. If I try to provide int here, I'm going to get a compiler error. You see, you will not be able to understand the compiler error message here, but this primitive data types are not allowed here. Only wrapper classes are allowed. Instead of int, you have to provide integer. Okay, because all these are objects, these are not values. If these are all values, you can provide the int primitive data type here. But since all these are objects, you have to provide integer wrapper class. Okay, that's the reason, guys, we are providing the wrapper classes inside this generics of this array list collections. Okay, fine. Next, coming to arrays, it's not like that, right? Arrays can be primitive data type and all those stuff. Okay, but coming to the collections framework, predefined classes in the collections frameworks or interface in the collections framework, we have to provide classes only, because all the collections framework predefined classes and interfaces will deal with the objects, not values. But arrays deal with both, guys. Okay, arrays deal with both. If I say integer a is equal to 1, 6, 9, this will work. Okay, here primitive data type. Here int is not allowed. If I say int here, it will give the compiler error. Okay, only the classes have to give. But coming to this is an array, guys. Okay, here this is allowed. At same time, object is also allowed, and wrapper classes are also allowed. Like this. Okay, this will work without any problem. So arrays can have primitive data types and wrapper classes and other classes. But coming to the array list or any other collections framework related predefined classes and interfaces, they only deal with the classes. Okay, because all are objects, not values. Arrays can have values and objects, but array list can have only objects. Values are not allowed. That's the reason wrapper class names or any other class names or okay, are required. Fine. Now few more things. So is it mandatory to provide the generic type of at the object creation end? What I mean to say here is, here we said array list of object, list is equal to new array list of object. Here this generic type is provided here and also here. That is declaration side we provided this generic, and on the object creation side also we provided this generic. But guys, the latest versions of Java, okay, it's mandatory to provide the generic type at the declaration side, but it's not mandatory to provide at the creation, object creation side. Okay, you see, you can make this generic type empty. Only one side it's mandatory. This side it's optional. You can provide. It's not a problem if you provide. And without providing also, it's not a problem. Okay, it's optional. Object creation side, it's optional to provide the generic type. Okay, so this will also work. Currently, as you can see at the object creation statement side, there is no generic type provided inside this generic brackets. Okay, still, if I run this program, it will work. You see, it's working. It's working, guys. Okay. So then, few more methods. Okay, few more predefined methods of this array list, or the methods which are inherited from the collections and list interfaces by this ArrayList predefined class. Okay, I'm going to demonstrate. The next method we have is the clear method, which belongs to the collection interface. This clear method is inherited by this ArrayList child class of this collection interface. Let me show you what actually it can do. Okay, so after adding all these objects to this ArrayList, if I want to clear all these objects at a go, I want to remove all these objects. Instead of removing each and individual object here, I want to remove all the objects. At a go, I want to remove. The method we have here is the clear method of this collection interface, guys. That is, I have to simply say list dot clear. This will wipe out all the objects from this array list. Okay. So after clearing out, if I print this array list, it will print nothing, guys. Empty list will be printed. Empty array list will be printed, guys. Okay. So here I am going to write using clear method to remove all the objects from the array list. Okay, so this clear method is going to remove all the objects from the array list. So if I run this, all the empty array list will be printed. You see, empty array list got printed, guys. Okay, because this clear method has cleared out all these objects that have been added to this array list. Fine. So that is the purpose of the clear method. If you want to wipe out all the objects that are added to the array list, then you have to use this clear method. The next method I'm going to demonstrate is another method known as isEmpty method. Okay, and this isEmpty method also belongs to the collection interface. Since ArrayList is inheriting this collection interface, we can use this isEmpty method with the ArrayList. So let's see system.out.println. I'll write some statement like before clearing. Okay, before clearing out the array list. At this place, the objects are still being added. And if I say here system.out.println list dot is empty, this is empty method will return Boolean value, right? If there are objects inside this array list, it will print is it empty? If the objects are there, is it empty? No, it will return false. This array list is not empty to state that it will return false. But after clearing, after wiping out all these objects from the array list, okay, system.out.println after clearing, okay, after clearing out the array list, if I try to print this, if I try to use the same is empty statement with this array list, then I'm going to get true, guys, because is empty. After clearing, no objects will be there in the array list. It's really empty, so it will return true Boolean value. Okay. So fine. So run this, right click, run as Java application. Before clearing out the array list, as we expected, it's false. Is the array list empty? No. But after using this clear method, everything got wiped out. So after clearing out the array list, is empty is returning true. Okay, that means the array list is empty. Since it is empty, when you print the array list, nothing got printed. You see, empty array list got printed here. Fine. So this is how we have to use isEmpty method to check whether a particular array list is either empty or non-empty. Next one. Next one is contains method. Okay, to check whether a particular object is available in the array list. Okay, we have to use this contains method. As you can see, this contains method is belonging to collection interface. Okay, and this array list, since it is inheriting the methods of the collection interface, we can use it. So guys, let me add few more things like list dot add of some Varun. List dot add of some Tarun. Okay, fine. Nothing to do about that. Now, guys, if I say system.out.println list dot contains, okay, contains object. Which object? If I give some existing object, guys, okay, if I give some existing object, some boolean value true will be returned, otherwise false. Okay, so let's say I will take one existing object out of this all the objects. Let's say there is an object known as some 3.56 contains 3.56. If this particular array list contains this 3.56 object, then it will return true, guys. This contains method will return true because in this case 3.56 is really available in this array list. Okay, 3.56 object is still is there in the array list, so it will return true. Okay, true. Or if I give some text like Arun, so what will be returned, guys? Is Arun object available in this array list? Yes, it's there, right? It will return true. But what if I give some non-existing object, like let's say Motori? Is there any Motori object inside this array list objects? No. So it will return false. This contains method will return false, guys. Okay. This dot contains will return false, and that will be printed by this print statement. So when I run this right click run as Java application, you see false will be printed. Next, we are done with the contents method also. Now let's move to the next method, which will convert an array list into an array. Okay. We want to convert an array list into an array, guys. So fine. So let's take another example here of an array list so that things will be good. Array list of string type. Okay. Some list is equal to new array list of, you can either provide this generic or you can ignore this. It's optional, guys. On the object creation side, generic type is optional. You can simply put less than and greater than. Now list dot add, I'll give the names Arun, string object type, because I clearly mentioned string object here, string class here. List dot add Varun, then list dot add, then Tarun, like these three objects I inputted, right? So what I have to explain, have to convert this array list into an array using toArray method. For converting, there may be some situations where you have to convert an array list into an array, guys. There you can use this toArray method. Okay, for converting the array list to an array. Okay, not to convert an array list into an array, we have to use this toArray method. So how to do that? I have to say list dot toArray. Okay, list dot toArray. Simple, that's it. You don't have to do anything. List is an array list and you want to convert it into an array. Over the mouse, what type of array it is returning, guys? Object array. Okay, no matter you specify string here, but still this toArray is returning you the which type of array. Return type of this toArray is object. It's converting this array list into an object array, guys. So here obj is equal to, I will say, and hover the mouse and say create local variable, it will add this object array. Whatever the return type of this toArray will be added here automatically by Eclipse ID. Fine. So but guys, I don't want to, this is fine for now, it's fine, guys. It's an object array, right? So let's say system.out.println. If I say obj dot of 1, will this work? This is an array syntax, right? How to retrieve the elements from the array? You have to say array reference and provided with some index value. If I say object of 1, since this array list has been converted into this object array, from that object array we are retrieving the value which is available at the index 1. Okay, object. Okay, right click run as Java application. You see, Varun got retrieved. That means this array list has been properly converted into the object array. That's fine. But guys, there is some condition. I want to do some more thing. Like I don't want to convert this like array list into an object array. Okay, instead of that, I want to convert that into a string array. Okay, what I have to do? I have to typecast, guys. Okay, before assigning this converted object array to this variable, have to typecast here saying string of, like this, string of array. Convert this object array. This to array will return you the object array of this array list, right? That array, that object array has to be converted to the string array. Okay. Over the mouse, create local variable. You see string array has been returned. Now system.out.println object of 1. This will also work. This is string array, guys. The return type here is string array. Okay, you have to do typecasting, small typecasting you have to do. Okay, it's up to you guys. So class cast exception is coming here. So list of what's happening. I converted to object of 1. I'm saying still looks like it's not converting. Okay, so fine. So this may not be possible, guys. So let's see. Let's go with another way to array. Add cast to string. So string is coming, but still system.out.println obj. This will also give an error, I guess. Yeah, this error is coming. This is not possible, guys. So object or should not cast it, I guess. I never tried this, so fine. Remove this. Don't go with casting. Normal object array. And if you print this object of 1, this will work again. Okay. Don't do any typecasting, guys. It's giving you some kind of error. Fine. Okay, this is working fine. So converting into string array is not working fine. Fine. Then what next? Next is this is not possible. Next is adding a particular index. So few more methods I am going to explain, guys. Okay, few more methods I am going to explain. That is, so far I have used normal add method, and which actually use objects for inserting the objects, right? But guys, there's one more method, similar method known as add method. As I already mentioned, this add method so far we have used belongs to the collection interface, add of object. But this list interface also has add object where you can even provide index, the index value at which you want to insert the object. If I simply say list.add, normal method, if I say list.add of, I say motori here, at which index value this particular motori will be added, guys. After all these objects have been added, at the remaining index value it will be added, right? 0, 1, 2, 3 will be added. System.out.println, if I say list, right click run as Java application, you see Arun, Varun, Tarun, Motori got added. But guys, I don't want to add this particular motori at this 4th index or the 3rd index, okay? But instead I want to add this at the index 1. So simply provide the index value 1, okay? Dot add of index value, comma the object. This particular statement is different from this particular statement. Here normal add method, which belongs to the collection interface. This add method of object is a collection interface. But here another method is there, add index of object belongs to the list interface, using which we can add the object at the required index. Here 0th index, now Arun will be added at 0th index. Since you have manually mentioned 1 of Motori, this will have the index 1. Then add of Varun will have the index 2 here. Then Tarun will have the index 3. Like this it will happen. Okay. So when you print this list, what will be the order in which it will be printed, guys? First Arun will be printed, which is at 0. Then Motori will be printed, which is at index 1. Then Varun, then Tarun. Arun, Motori, Varun, Tarun should be printed, guys. Okay. So let's run this. Right click, run as Java application. Arun, Motori, Varun, Tarun. This Motori string object has been added at index 1. That's why it came here. Okay. That's the advantage of adding the objects at the required indexes. Fine. And similarly, we have another method, guys, which can remove the object from the specified index. Okay. It also belongs to the list interface. Earlier, I explained about the remove object method of this collection. This remove object, guys. This is remove object. Whatever the object you provide to remove, this remove method will remove the object, which belongs to collection interface. But coming to the list interface, we have a alternative remove method. Using the index, it can remove the object. Okay. So let me show you. So let's say if I say list dot remove of, I have to provide some index. Let's say I will provide the here now index are like this 1 2 0 1 2. I want to remove some object which is available at the index 1. Okay, remove the index value. Okay, remove the object which is at the index value 1. So if I run this, what will be the output, guys? At the index 1, we have this Varun. Okay, Varun object. And also, guys, the return type is string. Why it's there, I will explain afterwards. Okay, for now, just understand. Remove of index value 1, that is Varun object should be removed. Okay, only Arun and Tarun should be left, that it should be printed here. And I print the list. Run as Java application Arun Tarun. Okay, the object which is there at the index value 1 got removed. Next one. Next one here is what I thought of explaining you is when I'm trying to remove, okay, it's returning you some string, guys. So I'll simply say the return type of this is string, guys. Okay, so removed object, you can say removed object is equal to whatever the object that you are removing using this remove method, that will be returned, guys. Okay, so it will remove it and it will return the object that is getting removed. So hover the mouse, since this is of string class type, the return type is string. So create local variable string remove. So system.out.println, the object, okay, the object plus this removed object got removed. Okay, I have to print something. I just want to print this remove method is removing the index, okay, object which is at the index 1. While it is removing, it is returning that object that is getting removed. Okay, so that thing I am printing in the output. At same time, after removing, I am printing the finalized list. So only this left objects will be printed. So right click, run as Java application. You'll get the proper output, guys. The object Varun got removed. Okay, that's the advantage, guys. The return type of this remove method we can use for printing it. Okay, to state that the object Varun got removed from the array list. Okay, only the left objects are Arun Tarun. Okay, like that. Fine. The next one, next method here we have the set method. Okay, so set method also belongs to the list interface set of index comma object. Set of index comma object. At a particular index, you want to replace an object. Okay, here you are providing some new object. In place of the old object, you are providing some new object. So let me explain. So what I mean to say here is, I want to replace one object here with a new object. Okay. Earlier, we have these Arun, Varun, Tarun objects added. Now, if I say list dot set of at index 0, I want to replace the value, replace the object, that is Arun object, with some Motori object. Okay. So here originally Arun object is there, but I want to replace that Arun object with Motori object at the which index? 0th index. Now if I say system.out.println list, what should be the output, guys? Since this Arun object will be replaced by Motori object, the output will be Motori, Varun, Tarun. Okay. So let's run this and see whether we are getting the proper output. Right click, run as Java application. You see Motori, Varun, Tarun. In place of Arun, Motori has replaced. The new object has replaced the old object. And similarly, guys, while the set method is replacing one object, older object with this new object, it has some return type again. Okay, it will return type will be, okay, it will return you the object that is getting replaced. So here the return type is string, guys. Okay, so I will say replaced old object is equal to okay, hover the mouse and say create local variable string replaced old object is equal to list dot set of, like this. So here the old object Arun is getting replaced with Motori. Okay. So while replacing this old object Arun with Motori, this method will return you the replacing the object that is getting replaced. That is Arun will be returned. Okay. Here. So here you can simply print system.out.println the older object plus replaced older object plus got removed, got replaced, I will say. Okay, got replaced with a new object. Okay, fine. So after that, if you print it, so simply Motori Varun Artarun will be printed, and before that, this message also will print it, which actually says that this older object got replaced. The older object Arun got replaced with a new object will be printed. Okay, for our communication purpose. Like this, we can use, guys. The older object Arun got replaced with a new object, and the latest array list is something like this: Motori Varun Tarun. Okay, so this is how it works. Next thing. Next thing is we are done with the set. Okay, then we have this other methods. So another method that I'm going to explain is index of method. Okay, index of method. So I want to retrieve the index value of a particular object in this array list. For that, I can use something known as index of method of this list interface. Okay, so if I say system.out.println list dot index of, I want to get the index of a particular object, that is, I want to get the index of the Varun object. Okay. If the object is there, if the specified object of this method is there inside this array list, then it will return the index value. Index value will be returned. Otherwise, if this provided object is not there in this array list, in that case, -1 will be returned. Okay. For now, when I say list.index of Varun, when I say list.index of Varun, it will check whether this Varun object is there in the array list or not. Yes, it is there. So index value 1 should be printed. Index value, the proper index value should be 1, should be printed. Let's run this. Right click, run as Java application. You see 1 got printed. But what if I give something like Motori here? Is this Motori object available in this objects of this array list? No, guys. There is no Motori in this objects of this array list. So it will return -1 in this case. In case of non-existing of existence of the object in the array list, it will return -1. So when I run this, right click, run as Java application, you see -1 will be printed. Like this it will work, guys. Okay. Then the next one, guys. The next method. Let's go to the next method, that is last index of object method. Okay. Last index of object. This is the one. Okay. Last index of object method also belongs to the list interface. Okay. Also belongs to the list interface. What is the purpose, guys? The purpose is to return the index value, but last occurrence of that index value. For example, here in this particular array list, we have list dot add Arun is there. Again, I will add some duplicate object like Arun. Okay. So what is the last occurrence of the array, Arun object here? What is the last occurrence? This is the first occurrence of the Arun. After that, this is the last occurrence. If I say list dot last index of Arun, it will return the index value of the last occurrence of this duplicated object. So here either 0 will be printed or 3 will be printed. Here I said last index of. This is not the last index, guys. Arun is there again at the different index. That is the next level index. So here output should be 3, guys. Okay. Output should be 3 because the last occurrence of Arun is at the index 3. Again, if I add something like, let me run this for now, let me add this, right click, run as Java application. It will print 3. Okay, this is working fine. If I add something list dot add of something like Motori, I will print. I will add. It's at the index 4. And if I add again list dot add of another again duplicate value, duplicate object Arun, I will add. Okay, at the index 5 add. This time, this last index of will return which value, which index value. This is at the first occurrence, second occurrence, last occurrence. So last occurrence of this Arun duplicated value is at index 5. So 5 will be printed. This is how it works, guys. Right click, run as Java application, it will return 5. Next. Fine. Next thing is assigning the object of array list to the collection interface. What will happen when you assign the object of this array list to the collection interface? I'll show you what will happen. Okay. So simple, guys. When you assign the object of this array list predefined class to the variable of the collection interface, like this. Over the mouse, import this collection from java.util. So what will happen is you will be able to access only the collection specific methods. Okay, that is list specific methods you cannot access, guys. Okay, list interface specific methods you cannot access. You see here, Arraylist class is a child class of the list interface and grandchild of this collection interface. When I am trying to create an object for the Arraylist class and assign it to the variable of this collection interface, using that object reference, I can only access the methods of this collection interface, but not list interface or Arraylist class. Methods specific to this collection interface can only be accessed, guys. Even though I'm creating an object for the Arraylist class, but I'm assigning that object to the variable of the collection interface. This will restrict you from accessing the methods of the child interface or child classes. Only the method specific to the collection interface can be accessed now. If I say list dot add, you see index object is not coming, only add of object is coming here. Okay. You are getting my point, right? In case of array list, if I say array list here, and if I say list dot add here, you see different methods are coming. Add method of object, add method of index comma object is coming here. Index, you see, as you can see here, collection interface has this add method as object, and in list interface has add method of index comma object. This is not coming when you make this collection, because on the left side we have the collection interface, which will restrict you from accessing the child class, child class or child interface methods. Only the collection specific methods can be accessed. That is list dot add can only be accessed here. Okay, this list dot add method belongs to which interface, guys? Collection interface, right? List dot add of object belongs to collection interface. That's why you are able to access. But not, you cannot say list dot add of some 2 comma Varun. You cannot say this. You will get a compiler error. Okay, you'll get a compiler error in this case, because you are creating an object of the predefined class to a variable of the its interface. Okay, variable of the interface. So only this interface specific methods can be accessed. This concept I already explained in as part of the interfaces in one of the previous videos, guys. If not, you can go back and get clarity on this. Okay, fine. Now, what if I create an object for the array list and assign it to the list interface? What will happen in this case? Import list from java.util. In this case, guys, you can access the methods which are specific to the list interface and its parent interface also. Okay, you are creating an object for the array list class and you are assigning to the variable of the list interface. That means list interface specific methods has to be accessed. Along with that, you can also access the parent interface of this list interface. That is, here list is a child of this collection. So list interface methods and its inherited method from the collection interface can also be accessed. So that's the reason, guys, when you say list dot add, you're getting both normal object from the collection interface. Okay, and also you are getting list dot add index at index 1 Varun also you are getting. Okay, like this is happening. So this is possible because object assigned to the variable of the list interface. So the method specific to this list interface and its parent interface can be accessed here. But child interface and child classes cannot be accessed. Okay, that you can have to understand. The method specific to this array list class cannot be accessed. Okay, I don't have an example here, but the method specific to this array list class cannot be accessed. Only the method specific to the list interface and its parent interface can be accessed here. That's the reason you are getting both methods. Okay, fine. Now the next thing, next topic here is sorting. Okay, let's go to the normal mode. I'll change it to array list. Array list string of list is equal to new array list. Okay, if I say list dot add of, I'm giving something like Motori. Just going to add some objects here. List dot add of. Then we have something like Arun. Then list dot add of Varun. Then list dot add of. Here I will say Tarun. Okay. So if I say system dot out dot println, otherwise before this, before this, if I say system dot out dot println list, what will be the what will be the output, guys? The order in which these objects have been inserted, the same order in which the output will be there. That is Motori, Arun, Varun, Tarun will be printed. Okay, first this Motori will be printed, then Arun will be printed, then Tarun, then Varun and then Tarun will be printed, right? The brackets like this. Motori, Arun, Varun, Tarun will be printed. Okay, the same insertion order will be preserved and will be printed. Right click run as Java application. You see, Motori, Arun, Varun, Tarun got printed as expected. But what if before printing this list, if I say list collections dot sort, okay, sort method of this list array list. This list I am giving here, okay, collections dot sort of list. If I say, and then I print it, what will happen? All these objects will be sorted, guys, in ascending order. Okay, what is this collections class? What is it a class? First of all, is this a class? No, guys. So let's go here. Yeah, collections, sorry, collections is a class. Okay, collections is a class. Collections and arrays both are classes. Okay, fine. Collections is a predefined class which falls under this collections framework, which falls under this collections framework itself. You see, there are like 3 categories, right? As I already explained. Collections framework, we have collections interface, map interface, and other miscellaneous classes and interfaces are there. And collections class is one of the miscellaneous class which is under this collections framework. Okay, the predefined class only. And using this collections class, we can sort any collection. Okay, so here collections dot this collections predefined class of this collections framework has a predefined method known as sort. Okay, and in this I have to provide the collection. Here array list is the collection type, the collections framework type. So list, if I say list, this list, the objects stored in this array list will be sorted using this sort method of this collections predefined class of collections framework. After getting sorted, how they will be sorted, guys? Alphabetical order. They will be sorted in alphabetical order. So as per the alphabetic, capital A will come first, then D, F, G, H, K, L, M, N, O, P, M, T, V. Okay, Arun, Motori, Tarun, Varun should be printed. Okay, Arun. After sorting in alphabetical order, it will be like this, right? Tarun and Varun should be printed. So before sorting, it was different order, insertion order was there. But after sorting, we got a different order. Right click run as Java application. Okay, Arun, Motori, Tarun, Varun got printed. This is how we can sort the array list using the sort method of the collections predefined class of collections framework. Okay, fine. Next thing. So few more methods we are left with. As you can see, this collection interface has some predefined method known as iterator, and this list interface has a predefined method known as list iterator. Okay, there are 2 methods left with. I am going to explain them. Fine. So here, to iterate through all this, objects of this array list, earlier I have used for loop, or we can use for each loop, right? Apart from using this for loop or for each loop, we can also use these methods. For iterating, we can also use this iterator and list iterator methods. Okay, there is a difference between this iterator and list iterator also, guys. List iterator is kind of advanced. I'll explain. Okay, I'll explain how the list iterator is advanced to this iterator method of this collection interface. Okay, first let's start using the iterator method. Okay, so instead of this for loop or for each loop, I'm going to use iterator method for iterating and retrieving the array list objects one by one. Okay, so fine, let me use it. So how to use this iterator method? I have to use it with the object reference only. That is, a list is the object reference. Simply I have to say list dot iterator. Okay, iterator method belongs to which interface? Collection interface. Okay, array list is the child class of this collection interface. That's why we can inherit and use it with the array list. List dot iterator I have to say. So this iterator will return you an iterator interface. This is an interface, guys. Okay, as you can see here in this hierarchy, there are different cursors, guys. Okay, under cursors we have this iterator interface. Okay, The return type of this iterator method. This iterator method belongs to which? Iterator method belongs to which interface? Collection interface, right? For collection interface, is a predefined method known as iterator. Iterator is a predefined method of the collection interface. As you can see here, iterator method is a predefined method of the collection interface. But the return type of this iterator method is what, guys? The return type of this iterator method is iterator interface. It is a different iterator interface is a different interface, right? It is actually at this point. It's actually at this. As you can see, under collections framework, we have collection interface, map interface, and other miscellaneous interfaces and classes. And as you can see, this iterator interface is here. Okay. The return type of this iterator method of this collection interface is this particular iterator interface. Okay. So this will return you the iterator interface. Since this array list of string type, it is returning you the iterator of string type only. So I will simply say itr is equal to, okay, hover the mouse and select create local variable. It will add the iterator of string. So this iterator method is returning you which return type? Iterator interface return type. And this iterator interface has its own predefined methods. Okay. This iterator interface, this variable is of which type? Iterator type, right? Iterator interface type. It has its own methods, guys. Iterator interface has its own methods like has, next, and next. Okay. Few methods of this iterator interface are as, next, and next methods. We can use this as, next, and next methods, okay, to iterate through this objects of this array list. Here, this array list objects have been, we have used iterator method with this array list predefined class to return the object of this iterator type. Okay, then using this object reference, we can use the iterator interface specific methods like as, next, and next. So how to use? While this particular itr object reference of this iterator interface, I'll call the methods of this iterator interface, guys. So that is itr dot as next. Itr dot has next. If this particular array list has some objects or not, that will be verified, guys. Okay. I'm not going too much technical here. I'm just explaining at a high level. We are using this iterator. We are able to convert this array list to an object of the iterator type. And here in this object reference, this complete objects are stored now. Somewhere the complete objects are stored like this. So something like this. Okay. All the objects are something like this stored in the iterator interface. The object reference here is itr. itr is the object reference I have given. Okay. Sorry. itr is pointed somewhere here. Let's say. Okay. The first object is Motori here. Motori is the first object. Then we have second object as Arun. Arun is the second object. Then we have Varun as a third object. Then Tarun is the fourth object. And using this iterator method of the collection interface, we have returned iterator interface type object reference. And using this object reference of this iterator interface, we can call the methods of this iterator interface. That is, what are the methods of this iterator interface, guys? As, next, and next are the two useful methods of this iterator interface that we are going to use for iterating through this array list now. Okay. So itr is pointed somewhere here. Okay. Then I'll write the program like while itr dot has next. Okay. While this particular itr is referring to an object which has some objects or not. Yes, there are 4 objects here. In this itr referring object, there are 4 objects. Has next will return true or false. The Boolean value will be returned, guys. True will be returned when there are any objects inside this itr. Okay. In itr object, if there are any objects left, itr dot has next will return true. So here while itr dot has next will return true or false. It will return true because there are 4 objects. Inside the itr, there are 4 objects. Okay. Now, I say system dot out dot println itr dot next. I will say another method itr dot upper next method. Okay, this method itr dot next. Other method I am going to use. This next method will point this reference. Okay, this reference will go from here to here. ITR will now point to this part. Okay, when you say next, this first index value will be referred to. So ITR dot next. At present, what is next will return you the string. Whatever the object that is referring to, that will be returned. Motory object is referring to, so it will return motory object. That motory object returned by this next will be printed. Okay, will be printed. This is how it works, guys. You have to practice this to understand. You see? So I didn't explain completely. First, what will be printed? The first object, that is motory, will be printed. Okay. First motory will be printed. After that, the control will again go to the itr dot has next. Okay, itr dot has next. Now the control will check whether there are any other objects left inside this. This one is already done. This first object is already done and printed. Now in the second iteration, it will check itr dot has next will check whether there are any other objects left in this itr object reference. Yes, there are 3 more objects left. Okay, so it will itr dot while itr dot has next will return true. The second iteration also it will return true and it will go inside the while loop. And itr dot next, this itr dot next, what it will do is it will move this reference object reference from here to itr reference will be moving from the first object to second object. Okay, this time Arun will be retrieved by this itr dot next and will be printed using the print statement. So next time Arun will be printed. Then again itr dot has next. Any other objects left? There are 2 more objects left. Again true. While itr dot has next will return true again. It will go inside the while loop. itr dot next. It will move the control from here to here. Okay, here to this Varun. Here to this Varun. Okay, fine. Now Varun is referred. So itr dot next Varun will be printed. After that again itr dot has next. Any other objects left? Yes, Tarun is left. Okay, true will be returned by this one. Then it will go inside the while loop. Then itr dot next, the control will move from here to here to Tarun. And itr dot next will return Tarun and that will be printed. So finally Tarun will be printed. Like this it will be iterated and retrieved, guys. Okay. So when you run this, and finally itr dot has next has to be executed, right? After 4 objects, is there any other object left? No objects left. So finally this will return itr dot has next will return false. And you will not go inside the while loop. So this is how this iterator method works, guys. Iterator method will return the object of this iterator interface. Using this object reference, we can use this has next and next methods, which will actually do this process. Okay. When you run this, right click run as Java application. You see all this Motori, Arun, Varun, Tarun got iterated and printed. This is about the iterator method of the collection interface. Iterator method belongs to the collection interface. And we have another method, guys, that is list iterator, which belongs to the list interface, not collection, list interface. Since Arraylist predefined class is also inheriting this list interface methods and both collection interface and list interface methods, we can also use this list iterator method of this list interface. Okay, we can use this list iterator in place of this iterator, normal iterator method. Instead of this normal iterator method, we can use the list iterator method, guys. Okay, and as I already said, list iterator method is the advanced version of the iterator method. What is the difference between this iterator method and the list iterator method? Iterator method belongs to the collection interface. List iterator method belongs to the list interface. And at the same time, list iterator method is advanced version of the iterator method. Advanced version of the iterator method. Okay. So why I'm saying this is advanced, guys? Because here, guys, let me show you. If we are going to use list iterator, it will be like this. Okay, list iterator method. It doesn't belong to the collection interface. Iterator method belongs to the collection interface, whereas List iterator method belongs to which interface? List interface, not collection. List interface. And this list iterator is an advanced, okay, advanced version of the iterator method. So it will return you another interface. This return type of this list iterator is going to be, here in this case of iterator method, we have the return type as iterator interface. But in case of list iterator, the return type is going to the list iterator type interface. Okay, where exactly we have this list iterator interface inside the collections framework? Let me show you. Under the other, we have this iterator, right? List iterator interface is a child interface of the iterator interface. Okay, so here guys, under the other miscellaneous classes and interfaces, we have this list iterator, which is as a child interface of the iterator interface. Okay, fine. So guys, how to use this? How to use this advanced, and why it is advanced? Because it's advanced because the iterator interface has only two predefined methods. Okay, as next and next. But list iterator is going to have same has next is there. Okay, whatever the has next method we have with the iterator is also there with the list iterator, and next method is also there with the list iterator. These two are matching, right? Apart from this, we have as previous. Okay, not only forward but also before also it can navigate. Then previous method. That's why it said advanced, guys. Okay, it can only navigate forward. Iterator methods can only iterator interface methods can only navigate forward. But here it list iterator has some methods not only for navigating forward. List iterator interface not only has a method for iterating forward but also for iterating backward. Let me practically demonstrate how to navigate backward using the list iterator interface methods. Okay, so here instead of I'll remove these statements. Simply I will use something like list dot instead of iterator. This is a normal iterator of the collection framework, right? Instead of that, I will say list iterator. Okay, instead of normal iterator, I will say list iterator. The return type of this method is list iterator, right? For the mouse, list iterator. Okay, you see LITR you can say list iterator. For the mouse, create local variable. Okay, list iterator of the string type, because this array list that you are converting is also of string type. Fine. Now, while this LITR, I'll simply say something like this. LITR dot next. I will say I'll manually move it forward. LITR dot next. What will happen, guys? There are four objects. Okay, LITR is referring to the here. When I say next, it will move to the first object. Okay, this will move to the moves to the object reference, moves points to the moves or points to the first object. Right? There are four objects. First object has been pointed out. Then manually I'm just moving, guys. List iterator. Now LITR points to the second object. LITR dot next. I'm not printing it. I'm just moving, guys. Okay. I'm just moving the object reference to point to the a particular point. That is here third object. That is Varun object we have moved to. So here I have to add next, guys. So it's automatically getting fine. Okay. Next. Control C, Control V. Okay. Okay, it's not able to do. So let me do it manually. Dot next. Okay, I have to manually select this. Otherwise, it's adding some other method. LITR dot again next. Okay, again the same thing happened. Dot next. This one. Okay. This points to the last object. There are only four objects, right? Only four objects. 1, 2, 3, 4. LITR next means it will point to the first object. Again next means second object, third object, fourth object. Okay. Using the next predefined method of this list iterator interface, we are able to go to this point. Now LITR is pointing to last object. At this point, if I say while, the status is something like this, guys. Here L is there. Okay. This LITR is pointing to Tarun now. Okay. After these statements, this LITR is pointing to Tarun now. Now if I say LITR dot has previous. Reverse, guys. We are going backward. Okay. Does LITR has any other previous? Yes. We have 4, right? 1, 2, 3, 4 are there. So system.out.println LITR dot previous, I will say. What will happen, guys? Now LITR will point to Tarun and Tarun will be printed here. First Tarun will be printed. Again, as previous. Yes, there are 3 more objects. So this cursor will move to Varun now. Okay. So Varun will be printed. When I say list.previous, it will print Varun. Then again, as previous. Yes, 2 more objects are left, Arun and Motul. Okay. So this will return true because it has previous. Then list litr.previous will print. We'll move the cursor to this object reference to this object. In reverse way we are going, guys. First we are printing Tarun, then Varun, then Arun, then Motori we are printing, right? So Arun will be printed here. Now again as previous. Yes, 1 more object is left. So then true. Then go inside list.previous. List.previous will move this object reference to this Motori. Okay. And it will print Motori here. And finally, has previous will return false because there are no other objects left other than this 4. And we'll come out of this while loop. So let's run this and see whether we are able to use this has previous and previous methods along with this next and has next methods inside this list iterator, which is an advanced version of the iterator, guys. Okay. And it belongs to the which interface? List interface. You see, first Tarun, last element Tarun, going upwards, Varun. We are navigating backwards, guys. From instead of top to bottom, we are going bottom to top, right? Using this as previous and previous methods, which are there in the advanced version of the list iterator interface, which are written by the list iterator method of the list interface. Okay. So this is all about the iterator and list iterator, guys, and how we can use with the Arraylist and how we can use these 2 things with the Arraylist. Okay. There's a concept behind that. Now, next thing is finally to conclude, guys. This is a conclusion, guys. Okay, this is a conclusion. So I explained a lot of things about the Arraylist in detail in this video session. Very lengthy video session, I understand. Okay, so I explained a lot of details about this Arraylist, but we have to understand where exactly we have to use, when exactly we have to use Arraylist. What is the proper way of using the Arraylist? What is the proper situation or situation that you get in while writing the program where we have to use Arraylist? The answer here is when you have to use Arraylist is Arraylist is suitable when your major operation is retrieval. Okay, when you want to retrieve, then Arraylist is best. How you will retrieve, guys? Get off index, right? Get off index is a method using which we can retrieve all the objects of the Arraylist. If your frequent operation, major or frequent operation is this retrieval using this get off index methods, then Arraylist is the best one to use. Okay, you have to use the Arraylist for this kind of purposes, guys. Where your retrieval is more or frequent, then Arraylist is the best. And how you will retrieve? Using get off index methods. Okay, but guys, this is where Arraylist is recommended. But there is some place where Arraylist is not recommended also. That is when your frequent operation is either addition or that means modification, you can say. When your frequent operation is modification, either addition, either adding or removing or modifying or replacing, you can say. Okay, using set methods or something. Okay, if your frequent operation is this modification, that is adding, removing or replacing, then Arraylist is not recommended, guys. Arraylist is not recommended to use in a program where the frequent operations are like adding, removing or replacing. We have methods in Arraylist. We have methods for adding, removing and replacing. What are the methods that we have for adding in the Arraylist? Add method. Okay, add object, let's say, or add index of object, whatever that is. Removing, we have remove index is there, remove object is there. Replacing, we have some method like set method, some index comma, some object. Such kind of things are there, right? If your frequent operation is to use such kind of methods, frequent I'm saying, not one time or two time. It's like every time a very big program and you are frequently using this kind of operations, then Arraylist is not recommended, guys. Okay. What is the reason? What is the reason why Arraylist is not recommended if you are modifying the things? The reason here is, let's say this is a array list and indexing is a concept behind the array list, right? And the memory, it will be stored something like this. Okay, the values that you store into the array list, add or modify or remove from the array list will be something like this. Let me explain. So some object one is there. I'm just writing object. Okay, you can treat it as Arun or Varun or anything. Okay, Varun, some object is there. Then Tarun, some object is there. Okay, object 4, object 5, and object 6. Okay, like this, there are something like this. Now you want to insert something in between. You want to add a particular object at particular index. Let's say third index, you want to add a new object. Some obj33, you want to add at this index 2. What will happen to the existing object that is there at the index 2? Okay, you are inserting this object at this point, guys. In between this 1 and 2 index, you want to insert this. So internally, memory point of view, what will happen is this particular object has to be assigned an index value as 2, right? Because it's coming in between 1 and 2. This has to be assigned 2. And these objects have to be moved to other indexes. Here instead of 2, this object has to be moved to index 3. Index 3. This object has to be moved to which index? Index 4. This object has to be moved to which index? Index 5. This object has to be moved to new index known as index 6, like this. So for a small insertion, all the objects have to change their places. This inserted object is getting a new index in between index, and remaining objects have to change their indexes. In memory, this is going to be moving to the right side or left side, something like that. Okay, because of if you remove something, if you also remove something, this object which is at 5 has to get the index 4, and this object at the index 6 has to get the index 5. So this also has to be moved. And this is a very small case. Only index values 0 to 6 are there. But in real case, if you have something like 100 index, 100 objects stored, just assume that lot of changes has to happen. For small modification, you have to assign these objects to different indexes. Internally, memory management wise, these objects have to be assigned to different indexes. Okay, so a lot of work has to be done. That's the reason, guys, for adding or modifying or replacing, which actually involves in changing the index values of the objects, existing objects, is a problem in case of array list. You should not use array list if your frequent operation is adding, removing, or replacing, because the objects has to be shifted to the right side or left side based on the index or insertions or removing or setting of something. Okay, but if your operation is only for retrieving, there is no problem. Okay, there's no problem. It's happy to retrieve, guys. Okay, whatever the index value you want to retrieve, directly it will go to the particular index and retrieve the object. It's very easy. Okay, it will find the index value and retrieve. That's why array list is recommended in case of frequent operation is retrieval. But if your frequent operation is not retrieval, instead of adding, removing, or replacing is there, then array list is not recommended. Okay, because of this problem. Fine. So this is all about the array list, guys, where exactly you have to use and what are the different things, different predefined methods of the array list we have to use for different purposes. It's a very lengthy session, I understand, and it's a very detailed one. And but array list is very important, guys. Okay, so in collections framework, array list is very important to learn. That's why I have to take the detailed session on array list like this. Okay, so hope you understood this array list concept, guys. That's it about this session. The next video session, I'll move to the next predefined class of the collections interface, collections framework, that is linked list class. Okay, it's almost similar to the array list, guys. The small differences between this array list and linked list, which I will be explaining in the next video session anyhow. Okay, so we'll move to the next video. In the next video, I'm going to explain the linked list collections framework predefined class. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 223 of Java for Tester series, that is linked list. So what is linked list? Linked list is a predefined. Linked list is a predefined class in Java. One of the predefined classes in Java. Okay. And it is a child class of the list interface. Okay, which belongs to collections framework. Collections framework. Under collections framework, we have several interfaces, predefined interfaces and predefined classes. And this linked list predefined class is a child class of the list interface. Let me show you visually. You go here, as you can see, this is a collections framework and it has several interfaces and classes. If you keep on expanding, they keep on coming. Okay. So several predefined classes and interfaces are there under this collections framework. At the high level, we have the collection map and other miscellaneous class and interfaces. And if you expand this collection interface here, you're getting some three other child interfaces like list, set, and queue, right? If you expand this one of these child interfaces, that is list interface, we are going to get this linked list predefined class. As I mentioned, linked list class is a predefined class and it is a child class of the list interface, which is a child of the collection interface and which belongs to the collections framework. So what is linked list? Linked list is a predefined class in Java and it is a child class of the list interface, which belongs to the collections framework. Fine. In the previous video, I already covered about Arraylist, right? Arraylist is also a child class of the list interface. Similarly, there is another child class for the list interface, that is linked list. Okay, already covered Arraylist in the previous video. Okay, I covered a lot of things in the Arraylist, guys. If you have gone through this Arraylist video session, that is a previous video. If you have gone through this Arraylist previous video, then you will understand this linked list in a easier way. So let's continue. So now you understood what exactly the linked list and where exactly it is placed inside this collections framework, right? Next thing is Arraylist and linked lists are almost similar. Okay, as I already mentioned, Arraylist is already covered in the previous video, guys. If not, you just go back and then cover it and come back here so that this session will be very easy for you. Otherwise, you may have to spend more time. Okay, better to go to this previous video on the Arraylist and come back here, guys. Fine. So what are the similarities then? Arraylist and linked list are almost similar, I'm saying. I'm saying that Arraylist and linked list both are similar. They work similarly. Okay, there are a few differences though, but almost they are similar. Okay, almost they are similar because both this Arraylist and linked list are the child classes of this list interface. As they are the child classes of this list interface, the first common thing they are going to get from the list interface is that indexing. Okay, indexing is there. Indexing concept is there in arrays or array list or anything. We have this indexing, right? So if you want to store some elements, they will be stored in the form like this, right? So you have the list of elements. Let's say object 1, object 2, object 3, object 4, object 5, something like this. And each and every object that is getting stored will be stored at a particular index. The first object will be stored at the 0th index, the second object at the first index, third object at the second index, and so on. Okay. So this kind of indexing concept is there with the there with the list interface and its child classes. All the child classes of this list interface has this indexing concept. Okay. Since Arraylist and linked list are also the child classes of the list interface, okay, they inherit this indexing concept where whatever the elements, whatever the objects that you are going to add to this Arraylist or linked list, okay, they will be stored on a indexing basis. The first element will be stored at the first object will be stored at the index 0 like that. Okay. So what are the benefits we are going to get because of this? Okay, the first benefit that you are going to get is insertion order will be same, guys. Okay, insertion order will be preserved. This is one benefit. That means if you add some object first and when you retrieve that, when you print that, you will get the same object first. Okay, the order will be same. When you print all the added objects, the way they got added, the same way they will be printed, retrieved and printed, guys. That means the insertion order will be saved. Okay, they will the first element will be printed first, first object will be printed first, second object will be printed, something like that. And second thing here is duplicates are allowed, guys. Okay, even though you add some duplicate objects to this array list or linked list, they're allowed. The reason here is because of indexing. For example, if I add Arun object here, and if I add the same Arun object here, they are okay. Okay, array list and linked list will accept. The reason here is they are separated with index. Okay, if you want to refer to this duplicate Arun, you have to go with the index 3. If you want to refer to this Arun, you have to refer with the help of index 0. Since indexing is taking care of the separation or differentiation part, duplicates are allowed. Okay, so even though there are duplicate objects inside this array list or linked list, okay, they can be easily differentiated with the help of index. That's the reason. With the help of indexing, duplicates are allowed, insertion order will be preserved. Okay, these are the benefits we are going to get. Fine. So both are same, guys, are almost similar. Array list and linked list are almost similar. So apart from this indexing part, how exactly this array list and linked list are similar? The second thing that we are going to face here is, as this array list and linked list are the child class of the list interface, and they are almost similar. They're almost similar. Okay. What will happen is, these array list and linked list classes are the child classes of the list interface and grandchild classes of the collection interface. List interface and collection interface, right? So all the predefined methods of the collection interface and the predefined methods of the list interface can be used with the objects of the array list and linked list. Okay. So I already explained how to use the predefined methods of the collection interface and list interface with the array list in the previous video, right? In the current video session, I will not show you all the methods because I already covered them as part of the array list in the previous video. So I'll take some sample methods out of this collection interface, some sample methods out of this list interface, and show you practically how you can use them with the linked list. Okay, how you can use them with the linked list. So let me show you a few then. So go here, the sample project with the sample class and sample main method. Inside this main method, I'm going to create logic for the linked list now. So directly create an object for the linked list. Linked list is equal to new linked list. Linked list is equal to new linked list. Hover the mouse and select import, guys. Import linked list class from the java.util package. Okay, fine. And then use this list. List dot. Let's use some predefined methods of this collection interface. There is a method known as add method, right? For adding the objects. So add of object. So let's add some objects. List dot add of object. Select this, and in place of the object, just give some object, say Arun. Okay. Then you can give another object also if you want. Add object something like 9. Okay. You can add some heterogeneous objects, not a problem, because we have not provided any generics here. Okay, generics concept also explained as part of the previous video, Arraylist previous video, guys. If you have gone through the previous video, you would have understood this generics right away. But anyhow, I'll explain that afterwards. Fine. Now list dot add of say I will use some Boolean value here, true. Okay, something like this. List dot add of I'll add something like Varun. Okay, Varun. So you can add as many number of objects. These are all objects, guys. This object 1, object 2, object 3, object 4, like that. Okay, using same add method, which I have used for the array list, I can use the same add method with the linked list. Okay, these are the similarities. This add method is from the which interface, guys? Collection interface. We have taken the add method from the collection interface. Similarly, you can use any of these methods, guys. With the linked list, you can use any of these methods. Whatever the methods that are there here, you can use them. And for example, you can also take some methods from the list interface also. Okay, that is add index of object. Let's take this add index of object. So this dot add, I'll give index, guys. Okay, instead of taking this dot add, I will take this, instead of taking add of object, I will taking index object. Okay, this method belongs to which interface? list interface, okay, with index list interface. Without index, if you are adding, that is collection interface. Okay, that's the difference. Fine. Here I am going to give some index value as 1, and here I am going to give some value as say Tarun. Okay, value say Tarun. Fine. So guys, this is a way of adding. If I want to system.out.println, if I want to retrieve any of these elements, objects, okay, retrieve the these are for adding. Now I want to retrieve. Which method I have to use, guys? As explained in Arraylist, we have to use a method known as get of index, which belongs to the list interface. Get of index we have to use for retrieving a particular. Simply you have to say list dot get of. Indexing concept is there, right? So get list dot get of some index you give. Let's say I give some index like 4. Okay, 0 1 2 3 4, because this is at 1, guys. This is 0 1 2 3 4. So Varun has to be retrieved. This is the index 4. Varun is the index 4 because this particular has been inserted at the index 1. 0th index, first index, second, third, fourth index, like this. Okay, fine. So Varun has to be printed. This is at the 4th index. Right click, run as Java application, Varun. Okay, done. Like this for retrieving. You can retrieve anything else. System.out.println list.get of 0 also you can retrieve. Anyhow, Arun is at the 0th index. So right click, run as Java application, Arun will be printed. Okay, like this you can use, you can retrieve. And also you can actually directly print the similar way you have printed array list. You can also print the linked list also. Simply print this object reference. Okay, all these things will be printed. Right click, run as Java application. You see all the things will be printed in this order. Arun, Tarun, 9, true. Okay, Arun at the 0th index. At the first index we wanted to Tarun to be inserted, so it came to the 1, and the remaining elements 2 3 4. 9 is 2, true is 3, and Varun is 4th index, like this. Okay, fine. So these are the common similarities. As you can see, these are very common, right? So the next thing here is, let me also show you the things that explained here. That is, duplicates are allowed, insertion order will be preserved, and one more thing is there, that null insertion is allowed. Okay, you can actually insert null. These 3 things. Let me explain now. Okay, so let me add few things like list dot add. If I add here Arun, list dot add. If I add here Tarun, and then list dot add. If I add here, sorry, let me add here Varun. Here let me add Tarun, like this. Okay, anything you can add. So fine. So if I say system.out.println list, in which order this particular objects will be printed here. If I print this list in which this particular objects have been added, in which order these objects will be printed in the output. The same order that you have inserted, the same order will be preserved. That means the insertion order is preserved, guys. Okay, insertion order will be preserved because this first object will be stored at the index 0, the second object at the index 1, third object at the index 2. Because of this indexing, the insertion order is getting preserved, and when you print them, based on this index, these objects will be printed. First object at the index 0 will be printed, that is Arun. Insertion order is also first, like that. Okay, then Varun, then Tarun will be printed. Okay, so if I run this, you can see that insertion order will be preserved. Arun, Varun, Tarun got preserved. Okay, the same way I inserted, the same way they got retrieved and printed. The order is same. Fine. Second thing is duplicates are allowed. So here already I added Arun here, but still if I want to add Arun there, is dot add. Same object I want to duplicate object I want to add. So if I add Arun here again at the index 3, you see already there is no compiler error coming. And if I run this will work, guys. Okay, without any problem it will work. Same, you see same order again, Arun, Varun, Tarun, then duplicate object Arun also got printed. So why the duplicates objects are accepted? Because this first duplicate object is at index 0 and the last duplicate object is at index 3. Since they are differentiated with the help of the index, linked list is allowing you to add duplicate objects. Okay, duplicate objects are allowed. Apart from this, I also mentioned that null insertion is allowed. Null insertion is allowed. If you don't want to add anything, okay, you have to add something, but you don't want to add any particular object, then you can simply insert a null. Okay. If you have to add something, but you don't want to add any object. Object means nothing, guys. Null means nothing. Null means nothing. At index 4, nothing will be stored. Nothing will be stored. So if I run this, you can see that null being stored in the linked list. Arun, Varun, Tarun, duplicate object followed by null. Okay, null means nothing. Nothing is there. No data is there or something like that. Okay, no object is there. Next thing. So these are good. Next thing here, we are done with the similarities, guys. Okay, we are done with the similarities. We can actually explore all these different methods with the linked list also. I already covered all these methods as part of the array list. Okay, if you want to go through practical demonstration and of each and every method that is of this collection interface or list interface, which can be used with this linked list. Okay, just go back to the array list video, that is previous video, where I practically demonstrated all the methods, predefined methods of this collection and list interface. Okay, you can apply those same methods with the linked list also. You can apply the same methods with the linked list also. Fine. So far, so good. We have covered almost all similarities, and you know how to use the predefined methods that are used with the array list with the linked list now, right? Now let's move on to the differences. Differences between the array list and linked list. This side we have array list, and this side we have linked list. Okay, what are the differences we have? The main difference, okay, the main difference between the array list and linked list is the purpose, guys. You have to understand where exactly you have to use array list and where exactly you have to use the linked list. Okay, and the reason behind that. Fine. So array list is more suitable if your frequent operation is retrieval of objects. If your frequent operation inside the program is retrieval of the objects, that is using some methods like get of index or something like that. If you want to retrieve the objects from the list, then you have to go with array list. Okay, array list is chosen when your frequent operation, mostly user operation in that program is going to be retrieval of objects. You want to retrieve the objects from the array list, then you have to use array list. Okay, and this is something like if your frequent operation is retrieval, then you have to go for array list. And array list should be avoided in case array list should be avoided when your frequent operation is addition, adding, or removing, or replacing, etc. Modifications. Okay, if your program is more frequently using these operations like adding, removing, and replacing, then array list is not the best solution for you. Okay, for smaller programs it's fine, but for bigger lengthy programs where you have the bigger size of array list, then if you are frequently using operations like adding, removing, or replacing, then array list is not the best thing for you. Okay, should not be using array list in case there are more frequent operations on adding, removing, and replacing from the array list. This is not suitable. There are methods like add method, right? Okay. There are some methods like you can insert in between also. 3 comma some Arun I can give, right? At the index 3, this Arun will be added. Arun object will be added. Similarly, for removing, we have something like this. Remove of index also is there. Remove remove of index. Okay, something like this is there. And replacing also, we have some set method. A particular index where you want to replace a current value with some other value. Okay, let's say like this. This kind of operations, if they are more frequently used in the programs, then array list is not suitable. Okay, linked list is something opposite to this one, guys. Okay, if you're if your frequent operation, the frequent operation is adding, removing, and replacing, then linked list is better solution. Okay, array list is not better for adding, removing, and replacing, but linked list is better for adding, removing, and replacing. And the other one is it's not suitable when your frequent operation is retrieval of objects. Okay, linked list should not be used when your frequent operation is retrieval of objects. Okay, it should be used only when frequent operation is modification kind of operations like adding, removing, or replacing. Whereas Arraylist is suitable for retrieval, linked list is suitable for modifications like adding, removing, and replacing. Okay, you have to keep this in mind, guys. Okay, so how this is how this is why I'm saying like Arraylist is suitable for this and linked list is suitable for that and all those stuff. Okay, thing here is this is all happening because of the memory management. Okay, so Arraylist and linked list manage the memory internally. Internal architecture, memory architecture is something different for Arraylist and linked list, guys. Internally, this Arraylist and linked list are managing the memory in a different way. That's the reason Arraylist is suitable for frequent retrieval operation. Linked list is suitable for frequent modification operations. Okay. So coming to the Arraylist, when you store some elements, they will be stored in this way, right? Let's say there are few elements here, objects here. When you store some objects into the array list, they will be stored like this. Okay, so the first object will be stored at index 0, second object with index 1, third object at index 2, 3, 4, like that. Okay, here we have object something, object 1, object 2, object 3, object 4, object 5. Object, let's say A, I will say. Okay, object B is there here. I'm just writing some dummy objects here. Okay, they are not realistic, but just for understanding, I'm writing here object D, say object E, and so on. Okay, now for retrieval, it is very easy, guys. For retrieval of objects, this array list is very easy. You can directly go and get some object and come back, right? Using get index because index value is there. So if you want to retrieve some object from the index 4, so index 4 is there directly. The controller will go to the index 4 and retrieve this object without any problem. Okay, directly we'll go to the indexes like this, right? So that's the reason frequent retrieval is easy, okay, or is beneficial. Frequent retrieval purpose, you have to use array list, guys, because you can directly go to the required index and retrieve the object. There is no problem, right? But if you want to add, like add, modify, or remove, replace any element, any object. So let's say I want to insert or add one object between this index 1 and index 2. I want add some object like obj, okay, x. Some obj x I want to add. At this location, I want to add. At the index 2, I want to add. What will happen in this case, guys? I want to make this as index 2. Already index 2 is there here, but you are forcibly inserting this object into the index 2. That's possible, right? We have the methods like add of 3 of here at the index 2. If you want add of 2 of this object x, you have to provide. This will insert it, right? But because of this, what is happening in the memory? In the memory, this new object is getting placed into the index 2, and the remaining objects which are and the existing object that is already at the index 2 has to move to the index. This one has to move to the index 3. Okay, so some operation is going on internally, memory management wise. Some operation is going on. This is being allocated with index 2, and this which used to have the index 2 has to be assigned to the index 3, and then this one which used to have the index 3 has to be assigned with index 4. Lot of shuffling is happening, right? Lot of shuffling is happening internally in the memory. The one which used to have the index 4 has to be assigned with the index 5. Okay, memory wise, lot of operations are going on internally. Okay, these are only five objects, but let's say if you have some 100 or 1000 objects, this is going to be very drastic, right? Just because of you adding some object in between, all the other remaining 1000 or remaining any objects, okay, almost in thousands, they has to be shifted to the different indexes. So internally this is happening. Visually you will not see any problem, but internally this memory management wise this is happening. That's why array list is more suitable for frequent retrieval, guys. Even though if you remove, also the same thing will happen, right? If you remove this object C, which is at the index 3, this one has to be given index 3, this one has to be index 4, because 3 is not there. 4 has to be become 3, 5 has to become 4, like that. Even if you replace also same thing. Okay, if you replace something or do something, the same things will happen. Fine. Next thing is how the memory management is there in case of the linked list. Let's find it out, and how, why it is supporting this modification things over the retrieval things. Let's find it out. So in case of the linked list, it will be stored something like this, guys. Okay, each and every object will be stored something like this. Let's say this is the starting point. Let's say this is the starting point. Okay, starting object. Let's say I will not give bigger names here. Let's assume that this is object A. Okay, so sorry. Let me draw a few boxes, guys. Control C, Control V, like this. Like this. Let's say some boxes are there, and in each and every box, you have to store. So this one is like this. Anyhow, it will be like index 0 or something. Okay. Index, this is index 1, index 2. Here's the diagrammatical memory management format is something like this. Here diagrammatic format is something like memory wise. This diagram is for the memory. Okay, the starting point is here, which is at the index 0. We have the object A saved. Here object B is saved, object C is saved, and here object D is there. Let's assume, and this is a ending point. Let's say this is the ending point, and let's take this thing, and here this one remembers. Okay, the memory, this one has a memory for connecting to the second object, and this part has a memory for connecting to the this part, and this one has a memory for connecting to the this part, like this. Okay, so like this, internally they are stored in the memory, guys. Now if you want to do frequent retrievals, if you want to do some frequent retrievals, so linked list is not supported, not the good solution for the frequent retrieval operations, right? For retrieving, you cannot retrieve directly, guys. What's happening is, suppose you want to retrieve something using like this, get of some 3 if you want to retrieve. Okay, get of 3, the object which is available at the index 3 you want to retrieve. So what happens internally is we have to start from the beginning, guys. Even though we have the index, the memory, the memory for identifying this object is not there here, guys. Okay, not there with the index. It's connected with the previous element. You see, the second index object 2 has the address of this index object 3. You are getting my point, right? So the address for this object which is at the index 1 is stored in the this part of the object which is having the index 0. Okay, so in order to get this object, first we have to go to this object, right? So what we'll do is, in order to retrieve get of 3, we'll start from the beginning, guys. So 0th index, it will connect to the second object having the index 1, because this one only has address for connecting to the second object. There is no other way. So we have to start from the beginning. From here to here we have to go. This is index 1. Still we have not gone to the required destination. So this one has a address for the connecting to the next object. So we'll go here. Index 2 has come. No match. Again, this one has address for going to the this object which has index 3. There is a match. Finally, D will be retrieved. So in order to get this object, we have to start from the beginning, guys, right? They have to come like this. If there are 1,000, there are like 1,000 or 10,000 objects like this, you have to keep on going till it takes a lot of time, right? That's why linked list is not recommended when your frequent operation is retrieval of objects like get index. Okay, it's only recommended when your frequent operation is like adding or removing, okay, etc. That is, for example, if you want to add some object at the index 2, say x object at the index 2, let's say. Okay, so here I want to add some object, insert some object in between. I want to insert some object inside this linked list, and that object I want to insert at the index 1. Okay, so what happens here is, already we have an object at the index 1, right? This also I want to insert at the index 1. So what happens is this communication will be breaked, guys. Okay, this connection from the 0th index to the first index, the connection is there, right? For remembering purpose, that is breaked. That will be removed. Okay, so this connection will go to the, now this connection will be simply linked to the this connection. Newly inserted object, it will be linked into. Okay, then guys, this connection is lost, but this connection is still there. This new connection has been associated with this one. Now this one will point to this one. Okay, you are getting my point, right? Automatically this one will become 2, this one will become 3, this one will become 4. You don't have to change anything, only you are changing the mappings. From instead of going from A to B, A is going to X and X is going to B. You don't have to change the positions of this C, D or anything in the memory. Okay, only the high level position, high level mappings are changing. Instead of the first object referring to the second object, okay, directly what's happening is the first object is getting linked to the inserted object, and the inserted object is linking to the second object. So this new connection has been introduced. The new connection will be something like this, guys. Okay, just follow the red part. New connection will be something like this. It will go to the second will go to the third now, third will go to the fourth now. Okay, automatically the indexes will automatically change internally, so not an issue. And because of this, guys, there are very less modification need to be done. Here everything should be shifted left or right, but here nothing shifted, only one element has to be mapped. Okay, so just mapping got changed, just mapping got changed, just mapping got changed. Okay, whatever that got introduced, a new mapping has been erased. Okay, simply a new mapping has been erased like this. So this one will be pointing to this one, this will be pointing to this one. Now this thing is already same. Okay, nothing, only this part will be breaking. Okay, newly inserted one, the link has been, this memory is referring to this memory, inserted memory, and this memory of the inserted object is getting referred to this memory. That's it, only this link has been changed, these mappings have been changed, remaining things are same. That's the reason, guys, if you add something or remove something, remove also same thing, guys. Okay, so what happens in case of I remove it something? Okay, let's say if I remove this B, this mapping will be lost, and this mapping will be lost, and directly this will be mapping to this one. Okay, this has been completely lost, right? Direct mapping has been done, remaining indexes and everything will be same. Okay, memory wise things will be same, only this one will be sent to the garbage collection. So that's why linked list is more suitable in case of frequent operation. In case of UI wise, guys, okay, when you run these things programmatically, you will not see any difference. Internally these things are happening, guys. Okay, this is just for your knowledge purpose. Why we have to use Arraylist in case of frequent retrieval operation, and why we have to use linked list in case of frequent modification operations. You have to know that in the case of memory, these things are happening. Okay, these things are happening in case of memory. If you know that, you will know the differences. That's the reason linked list is used in case of frequent operation is something like adding or removing. But if your frequent operation is like retrieving, you have to go for the array list. Okay, fine. So hope you understood that, and has a different memory management mechanism. That point is all about. Now this thing also I explained, and fine. Last thing, guys. That is a linked list. Apart from this inherited methods from the collection interface and the list interface, okay, linked list has its own. Okay, this particular linked list predefined class has its own predefined methods like this. Okay, these are the mostly used predefined methods of the linked list, guys. Apart from this predefined methods of the collection interface and list interface, you can use this predefined methods of the linked list to perform more operations. Okay, so let me show you. Let me take few things only here, like okay, I'll take only these two things. So if I run this code, what will happen, guys? Right click run as okay, right click run as Java application. Only two objects are added here. That is Arun object and Arun at 0th index and Arun at index 1. So Arun will come here, right? So apart from this, what you can do is you can add. You can use this methods: add first, add last. So what if I say list dot add first? Okay, I'll give some object like motori. So this will be added at index 0 because I'm saying add first. So whatever that is at index 0 will become index 1 and index 2 like this, right? So add first means at the first index we have to add. That is 0th index we have to add. And we have similar method like list dot add last. Opposite method for the add first is add last. Add last object. Okay, this will be added at the last. Okay, say Tarun at the index 4. Okay, because 0 is there, 1 is there, 2 is there. Sorry, 3, index 3. The last index is 3. So it will be added at the last. So if I print this list now, you will see the same thing. So first motor will be printed because it is at the index. Okay. Then after motor, what will be printed, guys? Index 1, that is Arun will be printed. Then Varun will be printed. Then Tarun will be printed. Let's run this. Right click run as Java application. Motori, Arun, Varun, Tarun. Like this. Motori, Arun, Varun, Tarun. Okay. So using add first, we can add the index 0. Using add last, you can add the last index. Okay, out of the available elements. Fine. Next predefined methods we have is add first, add last is done. We can retrieve also. Okay, we can retrieve them also. So what I mean to say here is, for example, I'll clear out all this stuff. Okay, list dot add of Tarun. This dot add of Motori. If I say something like this, and instead of using this print statement, what I'm going to do is system.out.println list dot get first. If I use this get first method of this linked list predefined class, it will get me the first element, right? First object. That is first object is at the index 0. That is Arun. So it will print Arun. If I run this, you will see that Arun will be printed because it is at the first position. Put semicolon here. Run this. Right click run as Java application. Arun will be printed. What if I say system.out.println list dot get of last object I want to print. 0th index, first index, second index, third index. At last index, we have this motori. So here motori will be printed. Save it, right click, run as Java application. Motori got printed. Okay, like this. Get off first, get off last. Add off first, add off last. Okay, there are different methods. Now we can remove also. At the same time, we can remove, guys. Okay. So if I say before removing, I will say before removing, I will print system.out. I will print the list. Okay, I'm printing this particular list. So before removing any element, so all these objects will be there. That is Arun, Varun, Tarun, Motor will be printed here. Okay. Now I will do some removal operations like list dot remove. We have this methods known as remove first, which will remove the first object. That is Arun object will be removed. Here Arun object will be removed. So it has some return type, I guess. Object return type is there. You can see here, right? So it is returning you the type of object that is getting removed. Fine. So you can simply say object first removed is equal to, okay. I can print it out. System.out.println object got removed plus the returned object, that is first remove. Whatever the object that is getting removed, that will be printed here. Here remove first will remove this object, guys. Okay, while removing it, it will return this object to this variable. Okay, I'm just printing that just for our communication part. Similarly, if I say list dot remove last, this will remove the last object, right? So this will also return some object. While removing this object, which is getting removed, will be returned. So I'll say removed last removed. Last removed is equal to, okay. For the mouse and say create local variable, it will be added. System.order for communication purpose, I will say object got removed. Which object got removed? This returned object got removed. Okay, last removed object got removed. Okay. Here, which object will be removed? Here, motori object will be removed. Done. Now, if I print the list, system.out.println, if I print a list here, after removing, if I print this list, what will be printed, guys? Because of this, what you call list dot remove first, this first object will be removed. Because of this list dot remove last, the last object motor will be removed. Only two objects will be left, that is Varun Tarun. So this will print only Varun and Tarun. Right click, run as Java application. You see, before removing, we have four objects: Arun, Varun, Tarun, and Moturi. Right? Then the first object got removed, that is Arun object got removed. Then the last object got removed, that is Moturi object got removed. After this first and last objects got removed, when you print the list, it has printed only the remaining objects, that is Varun and Tarun. Okay, this is how we have to use the remove first, guys. Remove first and remove last. So these are all the different predefined methods of the linked list, guys. Okay, these are all the predefined methods of the linked list. Okay, apart from the predefined methods of the collection interface and list interface, which are inherited by this linked list has its own specific methods which you can use. Okay, which you can use. So like this, and fine. So few more things left. Let me explain them. That is, so here linked lists are heterogeneous by default, right? So you can add any type of objects. So list dot add of string type objects. If you want to add, you can add, right? You can add string type objects like this. And by default, they are heterogeneous. Add of, if you want to add some integer objects, you can add integer object. This is an integer object, not an integer value. It's an integer object. Okay. List dot add some double object if you want to add. So let's say 3.56 is a double object. Then if you want to add some boolean object, you can add the boolean object also. Okay, this is a boolean object. If you want to add some character object, you can add the character object also like this. Okay, like this heterogeneous objects can be added. System.out.println, if I print the list, all these heterogeneous objects will be printed. Okay, all these heterogeneous objects will be printed. Right click, run as Java application. You see, all this got printed. This is fine. But there may be some situations where you want to only store the names. Names will be of, by default, names will be of which type is string type, right? But here I'm adding, I have to say names, right? So if I just make this names, it will be good. Names, 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 names. Okay, like this. I changed this, so I have to change everything. So I thought of adding the names, but my program is allowing the users to add the integer objects, the double objects, boolean objects, and character objects. But here names doesn't sense well, right? So context wise, it's not correct. But programmatical wise, it is correct. But context wise, names should have only string objects. But here I'm getting a different type of heterogeneous objects. To overcome that, there's a concept known as generics, which already covered in the previous video of Arraylist, guys. You can go back. Okay, you have to add some generics here. Okay, generics we have to add inside this less than and greater than symbol, and you have to provide here the object type that you want to store inside this linked list, that is string. So only strings will be allowed here. The same thing, you can either put this entire thing, or without this also is okay. You have to either put less than and greater than symbol you have to provide. You see, warning messages have also gone away, right? There used to be some warning messages, right? After adding the generics, warning message has gone away. Fine. Now here, guys, since this linked list will only accept the string type objects, but we are adding heterogeneous objects here. For all the other objects which are non-string type, you are getting compiler error. You see, you are getting the compiler error. The boolean, it's boolean. Instead of boolean, you have to add string. It is saying, okay, like this. So it will only accept string objects because you mentioned string here, or like this. The compiler errors are going away. Okay, like this. Fine. So like this, you can add. Only strings are allowed. Here now linked list will only accept the strings. It will not accept other object types. Fine. If you want to accept only integers, you have to give the wrapper classes, guys. Okay. Should not say primitive data type int here. It will give the compiler error. Okay. Only the classes are allowed here. Classes, and here objects will be allowed. So here you can say 9. 9 is an object. 3 is an object. Here integer object. 2 is an integer object. 5 is an integer object, and 1 is an integer object, like this. Okay. You can add like this. Okay, or if you still want the heterogeneous objects to be inserted, you can remove this. Okay, you can remove this. Heterogeneous objects will be allowed, right? So here 9, here Arun, everything will be allowed. but warning messages are coming. There's no problem with the warning messages. You can still run the program, right? You can still run the program, but if you still want this warning messages to be overcome and you still want this heterogeneous objects to be stored, okay, to be added, in that case you can add something like object class. Instead of wrapper class or string class, you can add the object class here. Okay, you see warning messages have been gone and all the warning messages have been resolved and we are able to add the heterogeneous objects. This is also possible. Okay, so like this, guys, these are the different ways to deal with the generics. Okay, this part is generics, guys. I'll explain more about in detailed version of the generics in the upcoming videos anyhow. Okay, for now just understand up to this mark. Fine. Next thing is I have created an object for the linked list, but I have created an object for the linked list, but I want to assign it to the variable of the list interface. Over the mouse and say import java.util, you have to say. Okay, here object is created for the linked list class and assigned to the variable of the list interface. So what will happen in this case? So here linked list specific methods cannot be accessed. Okay, in this case the linked list specific methods cannot be accessed, only the list interface, or we will directly make it collection, guys. Okay, initially we'll make it collection interface. We are creating an object for the linked list and assigning to the variable of the collection interface. Okay, so what will happen is here only collection specific methods can be accessed with the help of this object reference. Linked list specific methods cannot be accessed. Okay, so what will happen if I say names dot add first? Is it possible? No, you cannot access it. You'll get a compiler error because here the object is created for the linked list. Okay, but it is assigned to the variable of the collection interface. Because of this process, I already explained in the interface concept earlier. Okay, if you create an object for its child class and assign to the variable of the interface, okay, variable of the parent interface, then only the parent interface methods can be accessed. Okay, only the parent interface methods which are inherited by this linked list can be accessed, but not the linked list specific methods. Here add first is a linked list specific method which cannot be accessed because the object of this has been assigned to the variable of the collection interface. Only the methods which are specific to the collection and which are inherited by this linked list can be accessed. So you can access this add method without any problem because it is inherited from the collection interface. Names.add off. You see, you are able to do. This is possible. Okay, and similarly, what if similarly can I use this for can I use this names method, names object reference for accessing the predefined methods of this list interface? Even this is not possible, guys. Only the collection specific methods is possible. Collection interface specific methods only possible, but their child interfaces or child classes cannot be accessed. The methods of the child class or child interface cannot be accessed. This is the problem, right? This is how it happens when you create an object for the child class and assign it to the variable of its parent interface. Then only the parent interface specific methods can be accessed, but not their child interface or child classes. Okay, you can see that. So let's try to see. We have some method like add of index object. Can this be possible? If I say names.add, you see, only getting an option to add object, guys. Index comma object is not coming. If I still try to add, I'll get a compiler error. You see, I'll get a compiler error. This is not possible at all. Okay, I'm getting a compiler error. Fine. What if I create an object for the linked list and assign to the variable of this list interface? Okay, I create an object for the linked list and assign to the variable of the list interface. What will happen? Here also same thing. List is the parent interface of the linked list. So only the list specific methods can be accessed. Okay, only the list specific method can be accessed, and also the parent interface of this list also can be accessed. That is, list and its parent cannot be accessed, but not linked list. Getting my point right? So child class specific methods cannot be accessed, but list specific methods and list interface parents specific methods can also be accessed because list interface inherits the methods from the collection interface. So parent interface methods can also be accessed. That means here I said list objects names. So using these names, I can access add index, List specific methods are index, right? List specific methods are index, add of index object. That's possible. Add of 0 comma Arun, I can say this is possible now. At same time, we can use the parent interface. List interface as a parent interface known as collection. So this parent interface specific methods like add object can also be accessed. I can say names dot add of, I can say Varun. Okay, can be accessed here. Comma is there. Okay, like this is also possible, but not linked list specific methods. Linked list is a child class of the list interface, so it is not possible. So linked list specific methods are like add first. I cannot do add first now. If I say names dot add first, it's not coming. Okay, this is not possible, guys. So this is all concept about the interfaces, guys. Generally in interfaces, when you create a child class object and assign to the variable of its parent interface, only the parent interface specific or its parent interface can be specific methods can be accessed, but not the child interface or child class methods. Okay, for which the object has been created. So these things you have to keep in mind. Fine, guys, this is all about the linked list, which I thought of explaining as part of the linked list. And the next video session, we'll move to the next collections framework class, which is also there under the list interface, that is vector. Okay, here under this collections framework, under this collection list, we have this array list, linked list, and along with this array list and linked list, we have another class known as vector class, which I am going to cover in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 224 of Java for Tester series, that is vector. So what is vector? What is vector? Vector is a predefined class in Java, and it is a child class of list interface, which belongs to collections framework. Okay, so what is vector, guys? Vector is the predefined class in Java, and it is a child class of the list interface. So list interface in Java has several childs, right? What are they? List interface in Java has several childs. One of them is array list. Then we have linked list, and now we have vector. Vector is one of the child of the list interface. This is an interface, whereas vector is a class. Okay, then interface and vector is a class. So let me show you visually. So this is a collections framework under which we have several interfaces and predefined classes in the hierarchy. Let's open this collection interface here, and when you open that, we got this list, set, and queue as a child interface of the collection interface. Under list interface, we have these several child classes known as array list, linked list, and vector. So vector is one of the child classes of the list interface, which is a child interface of the collection and which belongs to the collections framework. Okay, so this is what is vector about. Fine. Now, how to use vector then? Okay, how to use vector and how exactly we can use it and all. Let's find it out. So vector works similar to array list. Okay, vector works similar to array list and with a minimal differences. Okay, there are a few differences between array list and vector, guys. Let me show you. So array list, and on the right side we have vector. Okay, let's compare them so that you can understand how vector is different from the array list. The major difference between the array list and vector is vector methods or vector specific methods. When I say vector methods, vector specific methods, okay, are synchronized methods. Synchronized methods. Vector class has its own methods, and all those methods are synchronized methods. They are synchronized. What actually the synchronized means? Okay, synchronized means single threaded, guys. Okay, single thread, only single thread. Only single thread will share the resource. Let's say this is some resource. Okay, this is some vector specific resource, and using these methods, only one thread will access the resource. Okay, memory resource. memory object or resource, anything you can call. Okay, memory object resource will be accessed only by the single thread. Single thread. This is the reason vectors are slow in performance, guys. Okay, slow in performance and okay, slow in performance. Coming to the array list methods. Okay, array list methods or non-vector methods or non-synchronized. Okay, non-vector methods are non-synchronized. That means they are multi-threaded. Okay, these methods which doesn't belong to vector use multi-threads. Multi-threads. The same object resource, memory object resource. Okay, memory object resource will be accessed at a time by multiple threads. Okay, thread 1, thread 2, like this. Okay, irrespective of whether this resource is busy or free, multiple threads will access this resource at the same time to complete the task. To complete the task, multiple threads will access the resource in case of non-synchronized methods. Okay, Arraylist uses non-synchronized methods where multiple threads will access this resource. Whereas vector has only synchronized methods, guys. Vector specific methods are synchronized methods where only single thread. That's the reason vector methods are slow in performance, whereas non-vector methods, that is Arraylist methods or any other methods, are speed in performance. Because of multiple threads, they are speed in performance. Okay. So at a high level, this is the only difference, guys. This is the only difference. And one more difference, if I have to speak about, is vector is a legacy, old class. Legacy means old. Legacy class. It came from the old Java versions. Whereas array is a latest class. Okay. Vector is a legacy class. Okay. Vector is a legacy class, whereas Arraylist is a new one or something like that. Okay. Fine. Next thing is, what are other similarities? Now these are the differences, you can say. High level, if I have to explain about the differences, vector, the main difference between the vector and Arraylist is they work in the same manner, but vector methods are synchronized methods, whereas Arraylist methods are non-synchronized methods. Because of that, Arraylist is speed in performance and vector is slow in performance. And vector is the older class. Okay, it's there in Java from long time, whereas Arraylist it came after the vector. Okay, after the vector in the latest versions. Fine. Now let's find out more about this vector and Arraylist differences. That is, here similarities are also there, guys. Okay, there are a lot of similarities between this Arraylist and okay, similarities between Arraylist and vector. Okay, so what are the similarities between Arraylist and vector? Indexing is okay. Both use indexing only for storing the objects. Arraylist use indexing and vector use indexing. Okay, all the objects will be stored according to the index. Okay, first object will be stored at index 0, second object at index 1, like that. Similar to arrays. Okay, similar to arrays, Arraylist, vector also stores the objects as per the indexes. Okay, vector also stores the objects according to the indexes. Only difference is this synchronized methods. Okay, vector legacy class has the synchronized methods where only single thread will access the or share the memory, which results in slow in performance. That's the only difference. And one more difference we can, as you can see already, the difference has been explained here. This vector has its own methods, I am saying, right? Apart from the Arraylist methods, vector has its own methods. Okay, vector has its own methods. That's the difference. Nothing more than we have to learn what are the different specific methods this particular vector has and how we have to use them. That I am going to demonstrate, practically demonstrate soon. Okay. So for now, coming to the similarities, Arraylist has indexing, whereas vector is also indexing. Okay. Arraylist is a child class of the list interface. Okay, child of list interface. Even vector is also the child of the list interface. Arraylist is a grandchild of the collection interface. Even vector is also the grandchild of the collection interface. Okay, almost everything is same. Everything is same except vector specific methods, which are synchronized methods, which came from the legacy class vector. Okay, that's the only difference. Nothing more than that. So anything else? That's great. So now let's move on to practical mode case. Okay, hope you understood the difference and similarities between the Arraylist and vector at a high level, right? So now let's move on to the practical usage of the vector. Okay, how to use the vector? We have to say vector v is equal to new vector, I will say, and we have to create an object for the vector class. Hover the mouse on the vector and say import vector from the java.util package. Now, using this object reference of this vector, we can access the vector specific methods, which are synchronized methods, and also non-vector specific methods can also be accessed. That is because vector is a child class of the list interface and grandchild of the collection interface. That means the predefined methods of this collection interface and the predefined methods of this list interface can be accessed by vector also. Apart from these vector specific methods, these are all the different vector specific methods, okay, which belong to the vector only. Okay, apart from this, using the object reference of this vector, we can access the parent, grandparent collection interface methods and parent list interface methods also. Okay, similar to Arraylist and linked list, we can access the grandparent interface methods and parent interface methods apart from the specific methods of the vector. Okay, fine. So let me show you a high level, like give you some high level usage of this object reference for accessing the grandparent and parent interface methods. Okay, before I explain you the vector specific methods, I will show you whether this vector object reference can access the methods of the predefined methods of the collection interface and list interface, which are the grandparent and parent interfaces of the vector class. Okay, so v dot, you see all the things are coming as add method we can use, add index. This is from the collection interface. Add of object is from the collection interface, right? So I have to add object directly like this. v dot add at index, particular index. At index 1, I want to add, say, Varun. Okay, I can use this also. This one came from the list interface. You can see here, list interface, we have add of index object. Okay, I'm able to use with the vector object reference. Collection interface, we have this add object. Like that, we can use all these methods and all the methods here also. And we can even use a get method of the list interface for retrieving them. Okay, system.out.println v.get of 1. If I say, it will retrieve this Varun and print. Okay, so if I run this, it will retrieve the 1 index 1 object, that is Varun. Okay, and also similar to Arraylist, we can print the vector. Okay, how to print the vector? We just print this object reference. All the objects added to this vector will be printed. Okay, same thing that we used to do with the Arraylist or linked list. Okay, you see both the objects got printed. Both the objects in the vector got printed. So all these things are similarities, guys. These are all similarities. You can use the non-synchronized methods of the collection interface and list interface using the object reference of the vector. At the same time, using this object reference or of vector, we can use the specific methods which are related to the vector class only. What are the different methods which are specific to the vector class? Vector class comes with this predefined methods known as add element, remove all elements, remove elemented elements, find element, last element, and size and elements. Let me practically demonstrate all these methods. Okay. v dot vector has for adding the objects, vector has specific method known as add element. Okay. So instead of this add, which is coming from the previous, we can actually use add element. Okay, add element of Arun, I can say. Okay, vector specific methods. And apart from that, I'll add few more elements. Add element, and I will say 9 integer object 9. v dot add element. You can add heterogeneous objects, guys. Okay, that's not a problem. v dot add element 3.56 double object, boolean object, integer object, and string object. Like this, you can add different type of objects. So system.out.println, just to check whether all these objects have been added using the add element synchronized method of this vector class or not. Okay, so for that I will print this v object reference of this vector to see whether they got really added or not to the vector. You see they got added, guys. Arun followed by 9, true, and 3. Here you see insertion order is preserved. The similarities are coming back, right? Because indexing is there here, And here, what are the advantages of indexing, guys? One is insertion order is preserved. Okay, first thing is insertion order is preserved. Second thing is duplicates are allowed, right? I kept on explaining about this insertion order preserving, duplicates are allowed, and null values are allowed. From array list and linked list, I explained all these things. Okay, you can refer to the previous videos, guys, array list and linked list, so that you can understand what exactly I am talking about. Okay, just because of this indexing, we are getting these benefits. Okay, here also insertion order is preserved. That means the way in which you added, when I printed, when I retrieved it or printed it, you see they got retrieved in the same manner. Arun 9 true 3.56. Okay, because insertion order is preserved because of the indexing. Similarly, duplicates also I can add. V dot add element. I can add Arun again. Okay, at the index 4, I guess I'm adding the Arun 0, 1, 2, 3, 4. At the index 0 already Arun is there, and at the index 4 also Arun is there. Okay, so duplicates are allowed because they are differentiated with the help of the indexing part. So these are the similarities, guys, between the array list and the vector. Okay, so you see Arun is added twice without any problem. Duplicate object is added twice. Okay, so insertion order is preserved, duplicates are allowed. You can even add the null values, null objects. If you don't want to add anything, you can, in place of the objects, you can add the null, guys. Null means nothing. At the index 5, I added null. Let's see whether it got added or not. Right click, run as Java application. Null also got inserted without any problem. Okay, these are all the common similarities between the array list, linked list, and vector, guys. Okay, because of the indexing, they behave in the same way. And apart from that, as I kept on explaining, this vector has its own specific methods, which are synchronized methods, where only single thread will be accessing this, sharing the resource or accessing the resource, which results in low performance. And vector is a legacy class. That's the only difference you have to understand, guys. Everything works same. Fine. Then coming to the add element, I am done. And for retrieving the elements, instead of the get method, this vector legacy class has its own method known as element it. Okay, instead of using this get method here, in the list we have this get of index method of the list interface, right? So similarly, vector also has its own method known as element it. Okay, synchronized method this is. So let's see that. So here I will say system.out.println list dot get of 3. Instead of get, I am going to use element. Sorry, it's not list, it's v, guys. In this case, we have used v dot element at. You see, instead of get index, we got element at index. Okay, I'm giving the index value as 3. So 0, 1, 2, 3. So double value, double object should be retrieved by this element at method. Okay, so you see 3.56 got retrieved as expected. Similarly, other method, let's go on. Let's use a remove. Okay, I will use v dot remove element. Okay, directly remove element. I have to provide the object. Which element I want to remove, which object I want to remove. I want to remove this boolean object. Let's say true, I will give. Okay, this true object will be removed, guys. Okay, out of this all objects added to this vector, this true object will be removed using the remove element. Okay, so when I print, after removing, if I print v, you see, except this true, everything will be printed. So let's run this. Right click, run as Java application. You see, except true, everything got printed, guys. Okay, Arun 9 true, 3.56, Arun null are there. Here true is not there. Okay, it got removed. Similarly, we have another method for removing, guys. That is remove element 8. Okay, which uses index for removing. Instead of taking input as an object for removing it, okay, it takes this v dot remove element 8. Okay, element 8, a particular index I want to remove. I want to remove an element at the index 3, let's say. Okay, 0, 1, 2, 3. 3.56 is there at this particular index 3. Okay, this element is going to be removed. If I print v after removing this element, which is object which is available at the index 3, all the remaining objects will be printed except that 3.56, which is available at the index 3. You see, Arun 9, 3.56 is not there. It got removed by using this method. Okay, so next thing is we are done with all these things. Remove all elements. Remove all elements will clear all the elements, guys. Okay, if I say dot remove all elements, v dot remove all elements, this will remove all the objects from this vector. That means all the objects will be cleared, and when I print, after removing all the elements, if I print v, nothing will be printed, guys. Okay, every object will be removed, completely wiped out. Okay, something like this. And the next one is we are done with this side, and let's go with this side. First element, last element, size, and elements are left. Okay, so let me explain about that. So now we have all these objects added. Around 9 true, 3.56 around null is there. So in that, I want to get the first object, first element only. System.out.println, system.out.println, v dot get what is that first element. V dot first element is a method. Okay, synchronized method of the vector class. So if I say this, what is the first element out of all these objects, guys? This is the first, Arun is the first object, which is at the index 0, right? So let's run this and see whether we are getting the proper output. Yes, we are getting that. So now let's move to the next method, that is last element. Okay, system.out.println, system.out.println, p dot last element. Okay, last element. If I run this, right click run as Java application, you see null is the last object. Okay, we added null at the end, so null got printed. Fine. Then size. So system.out.println, v dot size. Okay, it will give you the size of the vector, guys. 0 1 2 3 4 5. 5 should be the size. Okay, or 0 1 2 3 4. So 6, right? 6 elements are there, 6 objects are there. 1 2 3 4 5 6. 6 should be printed. Let's see what will be the result. 6 should be printed here. The size of the vector is 6 here in this case. Yeah, 6 got printed. Next thing is elements. So guys, before I explain elements, let me take back. Okay, elements is the specific method of this vector class. And do we have such kind of methods in the collection and list interface? Yes, in collection we have something known as iterator. Okay, cursor methods, cursor class related stuff. This is okay. So what I mean to say is, collection has this method known as iterator method. List interface has a method known as list iterator, which is an advanced version of this iterator method of this collection interface. Okay, this list iterator is an advanced version. Fine. And now coming to the vector, vector also has such kind of method known as elements. Okay, so iterator, list iterator, and coming to vector, it is elements. Coming to vector, it's elements. So let me explain about this elements now. So vector class, vector predefined class, which is a child class of the list interface, has a predefined method known as elements. Okay, and when you use this elements predefined method with the object reference of this vector class, it will return you. It will return you. What it will return, guys? It will return something called enumeration. Okay, enumeration. It's there somewhere here. Let's go to the other enumeration. It's also an interface, guys. Okay, it will return you the interface. Enumeration will be written. In case of iterator, which I already explained in the previous videos, we have this iterator, list iterator. Okay, this iterator belongs to the collection interface. Okay, this is a vector is a class here. I'm just comparing so that you will get a clarity on what exactly I'm trying to explain. List iterator belongs to the list interface like this. Okay, and the return type of the iterator is iterator interface. Okay, and the return type of this list iterator method is of this list iterator method belongs to the list interface. Okay, and its return type is list iterator is the interface. Okay, return type. So like this, coming to the vector, elements is a predefined method of the vector class, and its return type is enumeration. Okay, so this enumeration has its own methods, guys. Coming to the iterator, it has its own methods like has next and next methods. Okay, as next and next are the predefined methods of the iterator interface. Coming to the list iterator, we have more advanced methods like along with this has next and next. Along with this has next. List iterator also has previous and previous methods. But coming to the enumeration, it has more elements. Okay, some methods like let me practically show you v dot elements I have to say. Okay, if I use v dot elements, it will return you what, guys? This elements method will return you what? It will return you enumeration interface. As you can see, hover the mouse on these elements and see enumeration is being returned, guys. Interface, enumeration interface. So I will say en is equal to, okay, and hover the mouse on this en and say create local variable. Enumeration en is equal to vn, v dot elements. Okay, so I have to use something like this. While en dot has more elements. So here it has more elements. This is one, and there is like next element something is there. Okay, while this enumeration has more elements, I say system.out.println en dot next element. Okay, next element. Here we have next element. So I'm not explaining much about these things, guys. Okay, because if you understand this Arraylist and linked list videos which I explained in the earlier videos, you will understand what I'm explaining about this vector here. Okay, so I'm not digging more, but these are the methods of the enumeration interface, guys, which you can use now. Okay, so now it will iterate through all these elements and print one by one. So how this will work, let me explain at a high level at least. Okay, so let's say these are the different objects we have inside the vector. How many are there, guys? 1, 2, 3, 4, 5, 6 should be there, right? Here we have 6. So in the first we have Arun. The second we have 9. And third true we have. Then we have 3.56. Then we have again Arun. Then we have null, like this. Okay. And this object reference, that is en. Okay. Here I gave the object reference name as en, guys. You can give any name anyhow. And this en is pointing somewhere. Okay, it's not pointing anywhere. It's like at this particular state now. Okay, visually this is how we will understand, guys. Okay, so while en has more elements, are there any elements in the vector? Yes, 1, 2, 3, 4, 5, 6 elements are there. This will return true, guys. This will return true because the vector has 6 elements, 6 objects. Okay, has more elements, that is 6 objects are there, so it will return true. We'll go inside that. Now it will say en dot next element. When it say en dot next element, this cursor will be pointing to this one. When immediately when you say next element, this cursor will come and point to the first object. Okay, and you are printing that, and you are printing this object. So what will be done, guys? In the output, Arun will be printed first. Okay, then again the control will go to this condition, has more elements. Yes, 5 more elements are left. Okay, so again true. Again en dot next element. So when you say immediately when you say en dot next element, this cursor will come here. Now cursor is pointing to 9. So when you print that, 9 will be printed in the output. Similarly, the cursor will keep on moving. For every iteration, it will keep on moving, and all the elements will, and the vector, all the objects in the vector will be printed one after the other one, like this 3.56, and Arun, finally null. And after everything is printed, again when the control come back here, has more elements, all the 6 are done. So there are no other elements. This will return false and will come out of the while loop. Okay. So this is how, guys, we have to use the elements method, okay, which will return the enumeration object. Using the enumeration object, we'll get these 2 extra methods known as has more elements and next element, using which we can iterate through this objects of this vector. So when I run this code, you will see that all the objects of this vector will be printed. Okay, right click run as Java application. Arun 9 true, 3.56 Arun null. Okay, like this, all the objects will be printed. So we are done with cursors also, guys. I already explained about iterator, list iterator with the Arraylist, and then enumeration I was able to explain with the vector also now, right? So fine. Enumeration and enumeration methods I explained. Enumeration methods are nothing but has more elements, and next elements are the methods, predefined methods of the enumeration interface. Okay, we have to use elements method of the vector class to return this object reference of this enumeration interface. And using that object reference, we can access this has more elements and next element. So guys, these are all the different methods which are specific to the vector. I demonstrate all the methods, guys. Okay, add element, remove element, elements, fast element, last element, size, and elements. Everything is covered. Along with this, synchronized methods which are specific to the vector, we can also use the non-synchronized methods of the collection interface and list interface using the object reference of this vector class also. Okay. So guys, what is the difference now, guys? At a high level, what is the difference now between the array list and vector? Vector has its own methods, which are synchronized methods, where single threads will be accessing the resources. That's the reason the performance is slow. Coming to the array list actually uses the non-synchronized methods for accessing the resources and where performance is high. Okay, and vector is a legacy class, whereas array list or linked list or array list or linked list are the latest classes, whereas vector is a legacy class. These are all the only the differences. Apart from that, everything is similar between the array list and vector, guys. Okay. So guys, that's all about the vector. And before I conclude, you can even use generics, guys. Generics concept I kept on explaining from the array list and linked list also. You can, because you are seeing some warning messages here, right? Yellow color warning messages. Still it is working, but you can actually add object here, okay? Because you are storing some heterogeneous objects, right? So different type of objects. So you can add object here and you can put a empty less than and greater than symbol. This will work, okay? If you only want to store string objects, so provide string class here, and you will get the compiler errors here because you see these are not strings, guys. 9 is not a string, true is not a string, 3.5 is not a string, like this. If you provide only integers here, only integers value will be allowed. And when you try to provide any other type of objects like string objects or boolean or any other things, you are going to get the compiler errors. Okay. So these concepts I already explained as part of the array list and linked list. Just go back and watch those videos, guys, so that you will understand how to use the generics with the collection frameworks, class, and interfaces. Okay. So that's all about the vector, guys. We are done with the vector, and in the next video session, I'll continue with the next predefined class of the collections framework, that is stack. So somehow the stack is somewhere here under the collections framework. We have these things. Let's go back. So under collections framework, we have collection interface. Under collection interface, we have list, set, and queue. Under list, we have array list, linked list, vector. So we have stack here. Stack is the child class of the vector class, which I have just now explained in this video session, where vector is the child of the list interface. Okay. This particular stack predefined class, which is the child class of the vector class, I'm going to explain in the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 225 of Java for Tester series, that is stack. So what is stack? Stack is a predefined class in Java. Stack is a predefined class in Java, and it is the child class of vector class. Okay. Stack class is a child class of the which class? Vector class, which belongs to collections framework. Okay. Stack class belongs to the collections frameworks. Okay. Collections framework in Java. Stack class is a predefined class in Java and it is a child class of the vector class and which belongs to the collections framework. Let me show you visually. Let's go here. So this is all the collection framework we have. And this collection framework will have this collection map and other miscellaneous interfaces and classes. When you expand this collection interface, you are going to get another interface, child interfaces like list, set, and queue. Out of all these different three different interfaces we have, if you expand this list interface, okay, we have this array list, linked list, and vector classes. Okay, and this stack class is a child class of this vector class. Okay, stack class is a child class of this vector class, which is a child class of this list interface. And list interface is a child of the collection interface, which belongs to the collections framework. So this is the place where this stack predefined class of this collection framework belongs to. Collections framework belongs to. Okay, fine. So stack class is a predefined class in Java and is child class of the vector class, and it is a grandchild class of the list interface and also the grandchild class of the collection interface. So what are the benefits that this particular class will get when it becomes a child class of this vector class and other list and collection interfaces? That means that this particular child class can inherit all the methods from the collection interface. Okay, all the methods which are specific to the list interface, all the methods which also belong to the vector class. At the same time, stack class has its own methods. Okay. So stack class can use collection interface methods, list interface methods, vector class methods, and stack own specific methods also. Okay. Fine. So let's go to this collection interface method. These are all the methods which are specific to the collection interface. All these methods can be used by the stack class. Okay. And because this collection interface is the grandparent of the stack class. Similar way, list is also a grandparent of the stack class. So all the predefined methods of this list interface can also be used by this stack class. At the same time, stack class is a child class of the vector class. So all the predefined methods of this vector, specific methods of this vector class can also be accessed by the object reference of the stack class. Okay. And along with that, stack class has its own methods like this: push, pop, pick, empty, search. All these methods can also be accessed by the its own methods, so it can access. Okay. So like that. So stack class is the child class of the vector class in Java, which belongs to the collections framework. Fine. So next thing here we need to understand about the stack class is it's similar to other child class of the list interface, guys. Okay. In terms of, so here we have the list interface, and there are some child classes for the list interface like Arraylist, linked list, and vector. Stack class is also similar to the Arraylist, linked list, and vector. Okay. In terms of indexing. Okay. Stack class, because list interface, indexing concept is there with the list interface only. Okay. Indexing concept, list interface and its child classes. List interface and its child classes and grandchild classes have the concept of indexing. Okay. Whatever the elements you add to this either array list or linked list or vector or stack, they will have some index. Okay. When there is when there is a possibility of indexing, automatically, as we already know, insertion order will be preserved. The way in which you add the elements, add the objects, the same way they will be stored. At the index 0, first object that is added will be stored. At the index 1, the second object will be stored, like that. Okay. The same insertion order will be stored. So when you print out also, when you print out all the objects of this particular anything here, anything is either you print out the objects of the array list or linked list or vector or stack, the same order in which you inserted, the same order they will be printed out. Okay, they will be retrieved. So the insertion order is saved or preserved in case of this array list, linked list, vector, and stack. So complete list follows the indexing part, and all this have the insertion order preserved. And then we have the duplication objects allowed. Okay, that means because of this indexing, another benefit already explained as part of the array list, linked list, and vector class previous videos. I already explained, right? Indexing concept. Because of this, all these benefits, whatever the benefits that we get, I practically explained in the previous videos already. The same applies for the stack class also, guys. Duplicate objects are allowed. Okay, you can add duplicate objects because they are differentiated with the help of index. Even though you add duplicate objects, one of the object will have some index and the other duplicate object will have other index. So they will be differentiated. So list interface and its child classes like a stack, vector, array list, and the linked list allow you to add duplicate objects. Okay, because they can be differentiated with the help of the indexes. Finally, null insertion is allowed. Okay, even though if you don't want to add any specific object, string object or any other integer object or any double object, if you add null, null means nothing, guys. Okay, nothing will be added. Simply null object can be inserted. If you don't want to insert anything, you can add null. Anyhow, I will practically show you, guys. Okay, I'll practically show you all these things. So I'm going to show you, but before I show you, so we need to understand a few more things. Okay, so stack follows last in fine. Let me show you first then. So here, what I have to show, I'll show whether okay, this indexing and insertion order, duplicate objects, all those things I will explain you. Okay, so let's how to use stack then. So let's practically go and use stack. Okay, stack s is equal to new stack. You have to directly create an object for the stack, right? And hover the mouse on the stack and select to import the stack from the java.util package. Now, using this object reference, you can use many things, guys. Okay, so what I mean to say here is stack is a child class of the vector class. Stack is a child class of the vector class, and also child class of the list interface and collection interface. That means all the methods of the vector class, all the methods of the list interface, all the methods of the collection interface, everything can be accessed with the help of the object reference of this stack. So let's try it out. I'm not going to explain you in detail, but I'll show you whether you can access or not. If I say s dot, you see add of object is coming. Add of object belongs to collection interface. Add of object belongs to, you can inherit this one. Okay, you can access. Similarly, you can say add of index comma object, which is coming from list interface. Index comma object. You see, list interface specific methods also are accessible. Similarly, vector specific methods like add element can be accessed. So dot add of element. You see, vector specific elements like methods like add element is also coming. Along with that, you can also get stack specific methods. There are different stack specific methods like push, pop, pick, empty, and search. So push. Let's try to access push. S dot push is also coming. S dot push is also coming. So using the object reference of the stack class, you can access all the methods of the collection interface, list interface, vector class, and stack, because stack is a child class of the vector and grandchild of the collection and list interfaces. So I don't have to explain everything, guys, because you know how to use the, you already know how to use the predefined methods of the collection interface and predefined methods of the list interface and also the predefined methods of the vector class. Now, only thing that is left our end is like how to use this predefined methods of this stack class. Okay, that thing only I am going to explain. Okay, if you want to still experiment the predefined methods of its parent interfaces and classes using the stack object reference, just go to the previous videos on this vector, array list, and linked list, and then you can use the same thing with the stack, guys. It will work. Okay, fine. So now there is a method known as push, guys. Okay, there's a method known as push. Let me explain starting with push, guys, and I'll explain a lot more after push. Okay, so push is something like similar to add, guys. Okay, in case of vector we have this add element for adding an object. In case of collection we have add object. In case of list we have the add index. So all for adding, right? In the case of stack we have push, guys. Okay, we have to use push. So we have to say s dot push, you have to say, and you have to give something like let's say Arun. Okay, fine. Now if I say s dot push, if I give something like Varun, I give something like Varun, then s dot push, I'm adding multiple objects. Here I'm giving Tarun. Okay, I can give heterogeneous objects also, guys. Not only string type objects, you can give any type of, you can give integer objects, anything you want. Okay, s dot push, here I'm taking only string objects. Okay, fine. So if I say system dot out dot println, and if I print this s object reference of this stack, so what should be the output, guys? The output will be something like this. First Arun will be printed, then Varun will be printed, then Tarun will be printed, then Motori will be printed. So this is because the insertion order is preserved. If you are printing the objects of the stack, the way they are inserted, the same way they will be printed, guys. Okay, because they follow indexing, right? This one is at index 0, this one is at index 1, this one is at index 2, this one is at index 3, like this. Okay, so insertion order is preserved because of this indexing, and when you print out, the same order they will be printed. Okay, the same way they got inserted, the same way they will be printed, guys. So if I run this code, you will see the same output. Arun, Varun, Tarun, and Motori, because insertion order, based on the insertion order, they will be printed in the output like this. Okay, second thing I mentioned here is duplicates are allowed, right? Duplicate insertion order is preserved, indexing is there, duplicates objects are allowed. Okay, so duplicate objects in the sense s dot push. If I say s dot push, and if I give something like Arun here, Arun is already there, right? Arun is already inserted. Arun object is already inserted, but now I am again inserting it as a duplicate object. At the index 4, it's getting inserted, guys. Okay, so it will be allowed, guys, without any problem. It will be allowed. Similarly, null is allowed to be inserted. So if you don't want to insert any type of object, simply you can put null here. It will be done. Okay, at the index 5, null will be inserted like this. So when you print out, along with this Arun, Varun, Tarun, Motori, the duplicate object Arun will be printed and null also will be printed now. Okay, let's see that. Because all these concepts are common between Arraylist, linked list, vector, and stack, guys. Everything is common. Okay, all follow the same policies. Fine. Now guys, so you have used push, right? But you need to understand one more thing. Okay, you need to understand one more thing. That is, Even though insertion order is preserved and you are getting the same thing, result is same. Insertion order is preserved and it's getting printed as it is based on the insertion order. But you have to understand more about the stack, guys. Okay, stacks follows stack. This is not stacks, it's stack. Okay, stack follows last in first out policy. What does this mean? So diagrammatically speaking, it will be something like this, guys. Okay, when you are inserting some objects into the stack, they will be stored like this. Okay, let's say there is a vessel. Okay, just assume that there is a vessel kind of thing like this. Okay, it has some opening here. There is some opening here, guys. You can drop some objects here. Okay, like that. So a kind of vessel where you can store something, right? So when this particular statement is the first push statement get executed, when the first push statement gets executed, this object Arun object will be saved where? Will be dropped into this vessel. Okay, so like this. First Arun will be saved here. Okay, index will be 0 anyhow. Index will be 0 only. Okay, Arun with 0. Then the next statement s dot push Varun. Okay, will be dropped. So Varun got dropped here. Varun object got dropped here into this vessel like this. Why I'm explaining this kind of diagram, guys? Why I'm saying that this is lost in first out policy? Because the methods, when I explain the stack specific methods, you will understand. Okay, how stack is first in last out policy, how stack follows the first in last out policy, and how it retrieves all the elements and all the stuff. You'll understand. Okay. Second thing is then we have s dot push of Tarun. So when we say s dot push of Tarun, we'll get this third object. Okay, third object here is Tarun. Tarun will be dropped into this vessel. Then we have Motori. Okay, then we have Motori. So here Motori will be dropped. Okay, motor will be dropped. So now to avoid any confusion, I will remove these two items, guys. Only I will consider these 4 drops. That is Arun object got dropped, Varun object got dropped, then Tarun got, then motor got dropped using these push statements, push methods of the stack class. So once all these methods got dropped into this vessel, here index of this Arun is 0 and then it's 1, then 2. This indexing concept is same across the list classes. Okay, that's common. But the way it follows is different. This methods it follows is different. Now, when you use pop, okay, now there is a method known as pop, guys. Okay, so when I say system.out.println s dot pop, simply s dot pop, what will happen? It will retrieve the top element in the bucket. This is a bucket, let's say. This is a vessel or bucket, you are dropping the elements, whatever. So last dropped is motori, right? This one is on the top. This one is on the top. So this pop will pick the last element that is dropped into this vessel, that is motori element. Retrieve the last dropped element and remove also. At same time, it will remove it. Okay, it will not keep. So once it is, it will completely pick it out. Okay, this last dropped object will be completely picked out from this vessel. Only 3 will be remaining, right? This will be picked out completely. So when you say s.pop, this will retrieve this motori object from the vessel which is there on the top of this vessel, and it will delete it. Okay. So before deleting, I'll printing the yes. There are 4 objects, right? So 4 objects before deleting, 4 objects will be printed. After deleting also, I'll print yes. Okay. After s.pop, the last object that is motori will be retrieved and printed here. So here motor will be printed. At same time, it will be removed, guys. Removed means from the stack it will be removed. So only 3 objects will be left after this one s.pop. Okay. So you'll see that. So when I run this, right click run as Java application, you'll understand. First, how many objects were there? Arun, Varun, Tarun, and Motori were there. Then we popped out. We popped this Motori object which is there on the top, right? At the index 3, which are the last subject that got dropped. Popped out and removed. When it got removed, when you print this complete stack again, you're getting only 3 objects. Arun, Varun, Tarun. Motori got picked out, that is popped out, and removed also at same time. Okay, that's how it works, guys. Similarly, there is another method known as speak, guys. Okay, Peak also is similar to pop, but it's some there is a difference between pop and peak. Okay, let me show you. If I say s dot peak, if I say s dot peak, by this time when I started using peak, s dot pop is already done. That means here this motor is popped out. It's not there anymore, right? At this point of time, s dot pop has completely retrieved the top element from the stack and removed it also. So when by the time when the s dot peak comes up, what will be the top element, guys? Motor is not there, right? So the top element will be Tarun. Tarun will be retrieved. Here retrieves the top element. You can say here also top element. Pop also top element, but it removes it. But here peak will retrieve the top element, but won't remove it. Here difference between pop and peak is pop will retrieve and remove, whereas peak will not remove. Okay. System.out.println, if I print yes, the same output you will get. Okay. So it will not this here in this case top element Tarun will be retrieved and printed, but it will not be removed. It will be still there in the stack itself. In case of motory where we use pop, it has retrieved and also removed at the same time. But in case of peak, it will be there here, but it will not be removed, guys. So when I run this, you will see the difference. Right click run as Java application. You see Arun, Varun, Tarun, motory originally were there. So when I printed this, after that we have used pop, which has retrieved the top element from the stack, that is motory. Okay. Then it has removed also from the stack. It has removed because we have used pop. Then when printed this one, you see except motory, everything, all the objects got in the stack got printed. Arun, Varun, Tarun. Motory got retrieved here by the pop and removed from the stack. This is the result. Then the top element comes as a Tarun. So using peak, we have retrieved the top remaining top element, that is Tarun. So Tarun got printed here. And when you print the complete stack again, Tarun has not been removed, guys. Tarun is still there in the stack. So what happened is after peaking also, when you print this stack, all the remaining objects got printed. Arun, Varun, Tarun. Tarun is not removed from the stack. Unlike pop, where the retrieved element has been removed from the stack, in case of Tarun, that is with peak, it has been retrieved, but it's still there in the stack, guys. Okay, this is how the stack works. All the methods of the stack works. Then let's go with the empty, guys. Okay, empty will check whether stack is empty or not. Okay, if you want to check whether the stack is empty or not, s dot simply say empty. Okay, if you say s dot empty, it will check whether there are any objects in the stack or not. Yes, there are 3 more objects, right? After this, all these operations also, Arun, Varun, Tarun objects are there in the stack. So it will return what, guys? It will return true only. Okay, Boolean value true will be returned because stack is not empty yet. If the stack is empty, it will return false. Sorry, it will return false, guys, because stack is not empty. I'm just explaining in a different reverse way. S dot empty means is the stack empty or not? The stack is not empty. There are 3 more objects left, right? So it will return false only. Okay. If the stack is empty, then only it will return true. In this case, it is false only because there are still some objects left in this stack. 3 objects are there in the stack. So stack is not empty. So it will return false. Is the stack empty? No. That's the reason false. Okay, like this. Okay. So next thing is search, guys. Okay. We can search. So system.out.println s dot search. So what are the remaining objects left in the stack? Arun, Varun, Tarun. So if I search for Varun, let's say if I search for Varun here, what will be the output? You have to understand this. Okay. S dot search of Varun. So Varun is there, guys. Arun, Varun, Tarun is there, still there in the stack. So if you see this stack diagram also, Arun, Varun, Tarun is there. But what will be the output? The Varun is there. It should return something. It will not return a Boolean value, guys. It will return some integer value. The integer value is nothing but from top. From top of the bezel, only 3 objects are left. Tarun, Varun, Arun. So this is the position 1. Okay. Tarun is at the position 1 from the top. This Varun is at the position 2. From the top of the bezel, Varun is the position 2. From the top of the bezel, Arun is at the position 3. Right? From here. So when you say s dot search of Varun, Varun is found here in the stack, and it is at the which position? Second position from the top. From top, or Tarun is at the position 1, from top, Varun is at the position 2. So this position number 2 will be returned, guys. Okay. So this is how the search will work. So right click run as Java application, you will get the result as 2 because Varun is at the position 2 from the top of the stack. And also, if you try to give some value which is not there, okay, if I give something like Venkat, is Venkat there in the stack? No. What will be the result, guys? It will result something like -1. In case of not available, it will result -1. So I'm searching with Venkat, which is not there in the stack. You will get the result as -1. -1 is displayed. Finally, we are done with everything, right? So it looks we are done with everything. S dot search, empty, peek, pop, push, everything is done, guys. Okay. So this is all about the stack, guys. You can even implement generics in the same way I explained in the previous videos, like for array list, linked list, and vector. Okay, simply add string here if you want to store all the strings. Okay, you are not getting any compiler error because all these objects are of string type. Okay, yeah, you'll get rid of these warning messages also, as you can see. When I added this generics types to this stack class, all the warnings got disappeared. But if I add integer here, integer wrapper class here, you'll get all the compiler errors because you are adding the string objects, but you are mentioned it has integer object, which is not correct. So you have to provide integer objects to overcome these compiler errors. Okay, you can even provide object here where it accepts all the types of heterogeneous objects, either integer or string objects or integer objects or any type of objects. Okay, can be accepted. So again, I will change it back to string here so that since we are adding all the string type objects to this stack. Okay, this is all about the generics, guys. Anyhow, I'm going to explain generics topic in detail in the upcoming videos where detailed series of generics videos will be added to the same series. Okay, so for now, this is what is enough for as part of generics. Okay, so this part is generics. You can apply it to the stack also. Fine. So anything else left? This is all about the stack, guys. Hope you understood it. In the next video session, I'm going to explain the next topic of the collections framework, that is set interface. Okay, as you can see here under the collections framework, we have something like this, right? So under collections framework, we have collection interface, map interface, and other. When you expand the collection interface, we have 3 interfaces left: child interfaces, list, set, and queue. We are done with the complete list interface and its child classes now. So we are done with collection interface, array list, linked list, vector, stack so far in the previous videos. And the current video, I completed the stack also. Now after list interface, what is next? Set interface and its child classes and interfaces. Okay. I'm going to start the set from the next video session, guys, where I'm going to start with the set interface followed by these things in the upcoming videos. Okay. So guys, that's it about this video, and in the next video session, I'm going to start the set interface. So that's it, guys. See you in the next video session. Thank you. Bye.